Perfect. Here we go. Welcome to APEC, everybody. It is February 21st, 2026, and I am your moderator, Tim Ventura. Thank you to everybody for joining us on today's call, along with everybody who is watching us on YouTube. So today, Marat is going to be presenting a detailed overview of the legendary properties of bismuth. Chad Wanless will be discussing dark operational warp drive propulsion systems in a new peer-reviewed scientific paper. And John Brandenburg is going to discuss the findings of his new research article, Experimental Evidence of Possible Gravity Modification Based on an Einstein Unification Model, the GEM effect. So these are really, really exciting. I'm really pumped up about being able to showcase these for you, especially our first one here. Marat has dug into bismuth, so let me bring him in right now. Marat, welcome, sir.
Hey, Tim. Thanks for having me.
Oh, absolutely. So, as I mentioned before we went live, I am super excited because you have done a detailed drill down on the properties of bismuth. Let me bring that slideshow in there. And you're going to run through these. This is something that comes up in what you might call the legends and the lore, right? For energy and gravity modification and emerging propulsion. This community has been talking about bismuth for decades, and yet there's almost nothing out there about it. So thank you. You showed me this report actually on a separate call we were doing a couple of weeks ago, and I got so excited. I was like, please. So thank you, sir. Thank you for presenting it.
Yeah, absolutely. Hey, everyone. Thank you so much for being here today. My name is Marat. I'm a managing partner of a venture capital fund, Good News Ventures, and I'm genuinely excited, honestly a little nervous too, and to share this presentation with you. Today's talk is regarding legendary properties of bismuth, electrostatic inertia, and the new technological revolution. Now, that's a big title, I know, but I think by the end of this hour, you'll agree it's not an exaggeration. Bismuth has been floating around in frontier science folklore for decades. Most people know it as a cool rainbow-colored crystal you can grow in your kitchen. You've probably seen it on Reddit or YouTube, those beautiful staircase-like metallic structure with rainbow colors. Maybe some of you even grown them yourself. But there is something much deeper going on with this element, something that I believe has been staring us in the face for a very long time, and that's what we're going to dig into today. So yeah, let's get on the right. So here's our roadmap for the next hour. I've broken this into several acts, kind of like a movie, because I think the story really does build that way. We're going to start by asking a really simple question that nobody seems to ask. Why does bismuth grow the way it does? No, not what happens, but why. There's a big difference, and we'll get into that right away. Then we'll build up on what I believe is the hidden fundamental property behind it all. Something I'm calling electrostatic inertia. After the theory, I'll show you how mainstream science has actually been catching up to some of those ideas with papers from Princeton, McGill, and KIT, all published actually in the last few years. Then we'll talk what all that means. We'll look into real-world application and that are already using bismuth in ways most people don't know about. And we will explore some genuine strange anomalies in nuclear physics, and we'll end up in frontier territory with a kind of personal call to action. So let's get into it. So let's start with the obvious. Yeah, bismuth is beautiful. If you ever seen one of these crystal in person, you know what I'm talking about. It's honestly one of the most visually striking things in all of nature. The colors come from a thin oxide layer, and they change depending on the angle. It's like holding a tiny piece of a rainbow. And it's well known that bismuth is the most diamagnetic element at room temperature. That means it repels magnets. But here's the thing. Everyone talks about what bismuth does and what it looks like. Oh, it's diamagnetic. Oh, it grows Hopper crystals. Oh, look, pretty colors. Fine, but nobody seems to ask the deeper question: why does it grow this way? Why this specific shape? Why this specific geometry? Why is this the most diamagnetic element at not say lead or gold? So today we explore why. Okay, so here's where we start challenging the conventional narrative, so to speak. When you look up a bismuth crystal in textbook or on Wikipedia, they'll tell you that those are called Hopper crystals. The explanation goes something like the edges of the crystal grow faster than the faces, so you get the stepped staircase-like structures. The center of each face sinks inward because it can't keep up with the edges. And look, that's true. That is what happens. Observationally, it's accurate, but it's a description, not an explanation. It tells you the mechanism, but not the cause. It's like asking, why does it rain? And getting the answer because water falls from clouds. Okay, great, but why is the water up there in the first place? What actually driving this? I like to compare it to a tornado, a spinny wind. Technically correct, fundamentally useless for understanding why it forms, where it goes, and how to predict it. So what I want to do today is go beyond this description to get to the actual cause. Why do the edges grow faster? What's driving the specific geometry? What fundamental principle is at work here? Because once you answer the question, everything else about bismuth, the diamagnetism, the expansion, the extraordinary stability, it all starts to make sense as part of one unified picture. And that's way more satisfying than edges grow faster. All right, so before we go further, I want to give you a quick terminology guide because I've deliberately translated some concept into more accessible language for today. I don't want anyone to feel lost because of jargon. So the core idea today comes from a theoretical framework that uses the term dielectric inertia. For our purposes, I'm calling it electrostatic inertia. Same concept, just easier to grasp if you're not kind of steeped in that particular framework. And again, credits where credits is due. This framework builds heavily on the work of Ken Wheeler, on Missing Secret of Magnetism, Tesla, Steinmetz, among others, and I'll have full acknowledgement at the end. So when I say electrostatic inertia, what I mean is this bismuth internal field state is so saturated, so incredibly full of stored energy that it resists any external attempt to disrupt it. Think of it as the electromagnetic equivalent of a spinning gyroscope. But we'll get deep into that analogy later. It's going to be the key to everything. Similarly, where the original framework talks about counter space, I'll say convergent geometry, meaning inward collapsing. Where it says spatial, I'll say divergent, meaning outward expanding. Just two directions of the same fundamental force. Think of it like a breathing in, breathing out. Bismuth is the ultimate breathing in. So keep those terms in mind. They'll keep coming back throughout the talk. So here it is, the core claim of my entire presentation. If you take one thing away from today, let it be this slide. So I'm proposing that bismuth primarily property is not diamagnetism. Diamagnetism is the secondary effect. It's the consequence. The primary property, the thing that actually drives everything, is what I'm calling electrostatic inertia. So let me break it down in simple terms. Electrostatic inertia means that internal electrostatic field of bismuth is so incredibly saturated, so completely full, that it actively resists being charged by anything external. It's at maximum capacity. There is no room for anything else to get in and rearrange it. So when you bring a magnet near bismuth, the bismuth doesn't repel it in the way we normally think of repulsion, like two magnets pushing each other apart. It is more subtle than that. It just refuses to participate. It won't let its internal field be rearranged. It won't align. It won't play along. And that stubborn refusal is what we observe and measure as diamagnetism. So here is the key reframe. And please really let this land. Bismuth is not diamagnetic by nature. It's diamagnetic by consequence. The diamagnetism is a symptom. Electrostatic inertia is the cause. Flip this around in your head, and suddenly bismuth goes from being a kind of curiosity to being one of the most important elements on the periodic table. So now let's look at where bismuth sits on the periodic table, because its position is honestly kind of miraculous. It's been placed there by design. Bismuth is element 83. It has 83 protons and 126 neutrons. And 126 is what nuclear physicists call a magic number. It's one of those specific neutron counts that makes a nucleus extraordinarily stable. It's like hitting the jackpot in nuclear physics. But look at its neighbors. I mean, really look. To the left, you got lead, toxic, thallium, even more toxic, one of the classic poisons. To the right, polonium, one of the most radioactive substances. And then astatine, even worse, so unstable, barely exists in nature. And right there in the middle of this toxic radioactive war zone sits bismuth. Perfectly stable, perfectly harmless. You can literally drink it as medicine. And get this, if you add just one single proton to bismuth, you get polonium. One proton. That's how razor thin the balance is. And its half-life is roughly 1 billion times the age of the entire universe. For all practical purposes, it lasts forever. And it's quite rare, about 9 parts per billion in Earth crust. This is not an ordinary element. Now, this gets really interesting. There are 3 angles that show up all over nature, and they are all connected to golden ratio. Some of you may be familiar with some of these. First is 137.5, the golden angle of growth. This is the angle you see in phyllate axis, which is like how leaves, seeds, and petals arrange themselves on plants. If you ever counted these spirals on the sunflower head or a pine cone, you've seen these angles in action. It's nature's way of optimizing growth, packing the most stuff into the least space, galaxies and other things. Second angle, 85 degrees, what I call the golden angle of life. It shows up as a foundational angular constant in biological structure, related to complement of golden angle. And the third angle is 108 degrees, the golden angle of manifestation. This is the interior angle of a regular pentagon, appears throughout sacred geometry, very close to the bone angle in a water molecule as well. And here is the prediction that made this framework testable. If bismuth crystal geometry is really governed by a fundamental field principle and not just random edge growth rates, then the same golden angles should appear in structure. And it's been tested. Well, we'll get to the result in just a moment. So I want to introduce you a framework that's really helpful for understanding what's going on. Think of 2 fundamental direction in nature, 2 ways that energy can move. On one side, you have what I call space or divergent geometry. This is outward expanding, centrifugal. This is magnetism. Think of magnetic field lines radiating outward from a magnet. Like this is pyrite, which grows in perfect cubes, geometry pushing outward from a center point. On the other side, you have convergent geometry, inward, compressing, centripetal. This is electrostatic field that I'm talking about. Energy pulling inward, collapsing toward a center. And this is bismuth, which grows is what I call anticubes. The geometry is pulling inward, not pushing outward. And the beautiful thing, the same golden ratio governs both directions. The same mathematical principle expressing itself in 2 opposite ways. Pyrite and bismuth are like the inhale and exhale of the same breath. So, about that term, anticube, I really don't think Hopper crystal is the right name for what bismuth does. I think a more accurate and more meaningful geometric description is an anticube, or if you prefer the mathematical term, a hypercube, tesseract. And this isn't some new idea. 500 years ago, Leonardo da Vinci illustrated something called the solidus for the book of the Divine Proportion. The solidus is essentially the cube of space, the outward geometric expression, the framework of expansion. Look at bismuth crystal. Really look at it. It's not pushing outward like a normal crystal. Every face is sinking inward. Every step goes deeper. It's collapsing toward its own center, the stepped staircase geometry that everyone finds so beautiful. That's not a growth defect. That's the physical expression of an inward collapsing field. That's convergent geometry made solid. When you hold a bismuth crystal, you're holding the geometry of electrostatic inertia frozen in metal. So, okay, so all of this theory so far. Interesting theory, hopefully compelling theory, but still theory. The real question, can we test it? And the answer is yes. So I did it. So this is an anti-cast experiment, and it's been done not only by me, it was done by Ken Wheeler and other folks that I know. So the idea was straightforward. If bismuth geometry is truly governed by golden ratio angles, then when you force bismuth to solidify in a controlled environment, the angle should physically appear in the solid. You should be able to measure them. So here's the process. Melt bismuth. It's pretty low temperature for a metal, only 271 degrees Celsius. Pour it in a preheated aluminum mold. Like you can use it at the bottom of a can of a beer. And then preheating is really important. It prevents thermal shock and creates a more uniform cooling gradient, which lets the field geometry express itself more clearly. And here is what happened. The casting showed large divots, if you are in a triangular shape, and inertial patterns forming at precisely 137.5 degrees and 85 degrees, the golden angles, exactly as predicted by the theory. So I measured them. They are all real. They are reproducible. And then they appear exactly the position the framework predicted they would. All right, so here's another amazing property that fits perfectly. Bismuth expands when it freezes by approximately 3.3%. The liquid is actually denser than the solid. And in the context of this framework, it makes perfect sense. As bismuth cools and solidifies, the electrostatic inertia, that inward pulling convergent field, actually forces the crystal lattice to expand as it locks the field geometry in place. The field demands more space to express itself. But here is what really wild part. The solid seems to remember the field state of the liquid. Bismuth cools from the center outwards. And as it does, the geometry of the internal field gets frozen into the crystal structure. The solid becomes a permanent record of what the field was doing at the moment of solidification. Now, well, it sounds like a bold claim, but in 2017, a team published a paper in one of the most prestigious scientific journals in the world that proven exactly this. In 2017, a team from Yenshan University, the University of Chicago, and the Carnegie Institution published a paper in the Proceedings of the National Academy of Sciences. They took bismuth, remember, the single most diamagnetic element that exists, and they made it ferromagnetic. They literally flipped its magnetic behavior from one extreme to the other. How? By controlling the solidification process. They heated bismuth way above its normal melting point, past 1200 Kelvin, and then quenched it rapidly, cooled it super fast under pressure, and the resulting solid was ferromagnetic, not diamagnetic, ferromagnetic. So what that means for us? Well, the most magnetically resistant element in nature can have its field state completely reversed if you control how it solidifies. But the same paper found something even more profound, and this is the part that really connects to the framework. They discovered that liquid bismuth undergoes what's called a liquid-to-liquid phase transition at around 1200 Kelvin. The liquid itself fundamentally restructures at that temperature. It's not just getting hotter, it's reorganizing internally. And when they rapidly cooled it after the transition, the solid remembered the structure of the high temperature liquid state. The paper literally uses the phrase structural memory effect. This was the first time this had ever been observed in any pure element, ever. So the solid remembers the liquid. They called it a pathway in tailoring physical properties, quote unquote. meaning they recognize this could be used to engineer materials with specific characteristic just by controlling how the liquid solidifies. Moving on to this, another major validation. In 2022, a team at Princeton discovered that bismuth functions as a topological insulator at room temperature. This was published in Nature Materials. Now, for those who aren't familiar, what's a topological insulator? Think of it this way. It's a material that's an insulator on the inside. Electrons can flow through its bulk, but it conducts perfectly on its surface. It's like a ball that's made out of rubber on the inside, but coated with copper on the outside. The surface and the bulk behave completely differently. This is a quantum mechanical phenomenon. It's usually only observed at extremely cold temperature, and we're talking near absolute zero. But bismuth does it at room temperature. No special cooling required. That's a very big deal for potential application. And then in 2025, team at McGill University in Montreal published in Physical Review Letters showing something called the temperature-independent anomalous Hall effect. Temperature-independent is the key phrase here. It means that quantum behavior persists regardless of how much thermal energy you throw at it. Normally, heat disrupts quantum effects. In bismuth, the quantum state just doesn't care. If that doesn't sound like an inertial refusal to you, I don't know what does. The internal field state is so robust, so locked in, that even thermal noise cannot disrupt it. That's electrostatic inertia observed, measured, and published, but they just don't call it that way. Third validation made in February 2025, just a year ago. A team at KIT Technology Institute in Germany synthesized something called a B5 minus ring. Basically, 5 bismuth atoms arranged in a ring. Why should we care? Well, because it's the heaviest analog of something called cyclopentadienyl ever created. One of the most fundamental building blocks in organometallic chemistry, and now we have a version made of bismuth. The ring is aromatic, meaning the electrons are delocalized around the ring, just like in benzene. Opens up enormous landscape for potential chemistry, exploring application batteries, catalysis, gas storage. So the chemistry of bismuth is just getting started. For an element that's been known for centuries, we barely scratch the surface, and that to me is incredibly exciting. Well, bismuth isn't just a theoretical curiosity, it's already doing extraordinary things in the real world today. Nuclear reactors, thermoelectric generators, medicine. Bismuth is already there, working, doing its thing. Industry has been exploiting its unique properties for decades. They just haven't connected dots as to why these properties exist. And I think electrostatic inertia explain all of them. So the bismuth material properties are kind of insane. Melting point of only 123 degrees Celsius, stay liquid at relatively low temperatures, which mean easy startup, boiling points at 1600 Celsius, excellent gamma radiation shield. It doesn't react with water or air. So basically, it's a perfect nuclear coolant. But here is the part that's interesting. The lead bismuth eutectic is an excellent shield against gamma radiation, but it's virtually transparent to neutrons. Neutrons pass right through, it's like it's not even there. Now think about that through this framework. Gamma radiation is electromagnetic. It's divergent, it's spatial energy, outward expanding. Bismuth blocks it cold because its convergent field opposes divergent energy. But neutrons are not electromagnetic. They are on the convergent side of the duality, the same side as bismuth's own field. So they pass through unimpeded. Like recognizes like. Next up, thermoelectrics. Bismuth telluride has been the gold standard thermoelectric material since 1950s, over 70 years, and nothing has beaten it. Its Seebeck coefficient is around 250 microvolts per Kelvin, which is outstanding for converting temperatures differences directly into electrical voltages. Every portable cooler you've seen at the tailgate on a camping trip, probably running on a bismuth telluride via the Peltier effect. Many satellites power system, same material using the Seebeck effect in reverse. The fact that bismuth sits at the heart of the best thermoelectric material we've ever found is not a coincidence in my view. Its saturated electrostatic field properties make it uniquely suited for mediating between thermal and electrical energy. And here's my absolute favorite fun fact about bismuth. It's the only non-toxic heavy metal. Let that really sink in. Pepto-Bismol, the pink stuff you drink when your stomach is upset, has been around since 1919, like over 100 years. You literally drink a heavy metal compound and it makes you feel better. So, but again, look at the bismuth neighbors on the periodic table. Lead, toxic, causes brain damage. Thallium, nicknamed the poisoner's poison, one of the most lethal elements known. Polonium, highly radioactive. And right there in the middle of this, bismuth, safe enough to sell at the CVS. Why? How is that possible? Again, electrostatic saturation prevents harmful biological binding. The internal field is so locked in, so inertially stable that bismuth simply cannot interact destructively with biological molecules. It's too full, quote unquote, to participate in toxic chemistry. All right, so we've seen the practical side. Bismuth already working in the real world. Now let's go deeper into territory that's genuinely strange. So there are 4 natural radioactive decay chains in nature, 4 series of unstable elements that progressively decay through alpha and beta emission until they reach a stable endpoint where the decay stops. 3 of them end at lead. The thorium series ends at lead 2A, the uranium series lead at 206, actinium series at lead 207, lead, lead, lead. Stable, unremarkable, done. Lead is the default good enough endpoint, stable enough that the decay process stops. But the 4th, the neptunium series, ends at bismuth 209, not lead, bismuth. So think about what that means. In 3 out of 4 cases, nature radioactive cascade settles into lead, which is perfectly stable. But in one special case, nature goes one step further. It doesn't stop at good enough. It reaches bismuth, the heaviest stable element in existence, the maximum possible electrostatic saturation point. Bismuth isn't just another stable endpoint. It's the ultimate endpoint, the place where nature's transmutation process finally, completely, definitely stops. As far as we know, there is nowhere else to go. I really don't think that's a coincidence. Here's an anomaly that really makes you stop and think. The bismuth 209 nucleus has a higher total energy than the sum of its decay products, thallium 205 plus an alpha particle. In normal nuclear physics, when a nucleus decays, it releases energy precisely because the products are more stable, lower energy than the parent. The products weigh slightly less than the parent, and the missing mass becomes energy via E and mc squared. That's how nuclear power works. Parent heavier, product lighter, difference equals energy release. But with bismuth, that math goes backwards. The nucleus appears to contain more energy than what you would need to assemble it from its component parts. It's like a battery that somehow holds more charge than was ever put into it. Mainstream physics handles this by noting that bismuth 209 has a very, very slight alpha instability, hence the absurdly long half-life. Fair enough, that's accurate. But in this framework, this makes even deeper sense. The electrostatic field is saturated beyond the normal equilibrium point. It's overcharged. The extra energy isn't a mystery. It's the inertial tension of the saturated field itself. It's literally a nuclear scale field battery running at 100% capacity. Well, this is the most important analogy in the whole talk. So I want to really take our time with it. Think about a spinning gyroscope. When a gyroscope is spinning fast, it does something magical. You can push it, you can tilt it, you can tilt the surface it sits on. You can even try to turn it sideways, and it just keeps pointing the same direction. It resists being reoriented. But, and this is crucial, it's not pushing back against you. It's not generating counterforce. Its angular momentum creates an inertial state that simply refuses to change. It's not fighting you. It's just not participating. It's locked in. Bismuth does the exact same thing with magnetic fields. When you bring a magnet close to bismuth, bismuth doesn't actively push the magnet away like another magnet would. Its internal electrostatic field is so saturated, so completely locked in, that it simply refuses to be rearranged. The field won't align. It won't budge. It's inertial refusal, not active repulsion. This distinction matters enormously. Repulsion implies an active expenditure of energy. You push me, I push you back. Inertial refusal is completely different. It's passive. It's just a state that happens to resist change, like a gyroscope that happens to not fall over. And here is where the paper connects beautifully. They proved that you can overcome this refusal if you apply enough pressure and heat, extreme conditions, just like a gyroscope. If you grab a gyroscope and really force it, with enough sustained torque, you can eventually tip it over. The analogy holds perfectly at every level. So when someone says bismuth repels magnets, that's not quite right. What's really happening is more profound. It's a gyroscope that won't budge. So if bismuth is this saturated, inertial locked field state, what does that really mean in terms of energy? I want you to think of it as a battery, a fully charged battery of electrostatic field energy. An atomic number 83, bismuth sits an absolute limit of nuclear stability. It's packed with as much potential kinetic energy as nature can cram into a stable configuration without it tipping over into radioactive chaos. As we know, thanks for the researcher teams that you can flip its field state, the battery can be switched diamagnetic to ferromagnetic and presumably back again. The energy is in there and the state can be changed. So the obvious question becomes, what if you could tap that energy? What if you could find a controlled way to release the stored inertial tension? Not destructively, like a detonation, but in a controlled, repeatable way. That's where we move from observation into hypothesis. And again, I want to be very clear and honest about this. What follows is speculation. It's informed speculation, grounded in everything we just reviewed, but it's speculation nonetheless. Keep that in mind. So, so if someone wanted to actually test this hypothesis, here's the free stage roadmap I came up with. Stage one is, I think, probable cause of field manipulation using Hallback arrays, golden ratio geometry to create precise field condition around bismuth samples. We know from the casting experiments the golden ratio spacing is fundamental to how bismuth responds to fields. The stage is about getting, I guess, the geometry right. Another experiment is the electrostatic saturation, charging the bismuth to its lattice limit with high voltage. Again, the team at the PNAS results validate this kind of extreme approach can fundamentally alter bismuth field behavior. We need to explore the parameter space. And stage three is proton bombardment, stressing the nucleus right up to the edge of instability. This is the most ambitious stage, I would say, and it's where we need real experimental physicists, people with access to accelerators, high voltage equipment, and the expertise to do this safely. So pulling all of this together, where does everything we've discussed today actually lead? I see 5 major application domains. Propulsion, using convergent geometry principle for fundamentally new forms of transportation. Energy, harnessing electrostatic inertia for clean, powerful energy generation without combustion or nuclear fission. Materials, programming materials at the field level rather than just the chemical level, creating a whole new class of engineered metamaterials. Computing, Bismuth topological insulator properties make it a genuine candidate for room temperature quantum computing substrates. And again, medicine beyond peptide bismuth, targeted bismuth nanoparticles for drug delivery, imaging, and therapy. Every single one of these is grounded in research we discussed today, and then this isn't science fiction. So if I had to distill the entire presentation down to one sentence, one takeaway, it would be this. Bismuth is the purest expression of extreme electrostatic inertia in the periodic table. Not the densest element, not the rarest, not the strongest, but the most electrostatically saturated stable element in existence. And every single anomaly we discussed today, the crystal geometry, the diamagnetism, the expansion and freezing, the structural memory, the non-toxicity, the decay chain endpoint, the overcharged nucleus, the topological insulator behavior, every single one flows from this single underlying principle. One cause, many consequences. That's the, I guess, hallmark of a good theory. Yeah, but here's the kicker, and I want to leave you with this thought. Everything I talk about today, like electrostatic inertia, convergent geometry, field saturation, this is just one of 4 fundamental field modalities, 1 out of 4. And Bismuth is the purest expression of one of them. But there are 3 more, and when you understand all 4 and how they interact, how they conjugate, how they create the phenomena we call magnetism, electricity, gravity, and matter, you'll start to see a unified picture of physics that's far more elegant, far more powerful than anything in the standard model. That's the material for my next presentation, I guess. But today was the gateway. Bismuth was the kind of foot on the door, the most tangible, most beautiful, most accessible expression of this deeper reality. And I hope I've shown you that the door is worth walking through. Yeah, here are the key reference for everything I've covered. I would specifically encourage you to read Ken Wheeler books, Uncovering the Mystic Secret of Magnetism, PNAS paper, Princeton, McGill, key papers are all searchable throughout the respective journals. And Ken Wheeler's book is available online. Dig into this, form your own conclusion. And yeah, thank you for all spending time with me today. I know this was a lot of information, and I really appreciate you sticking with it. This is the theoretical framework is in place. The pieces are on the table. What's been missing, I guess, is the experimental side. I'm actively looking for like-minded people, physicists, engineers, experimentalists, thinkers, makers, anyone who has the hands-on capability to design and run real experiments, because the ultimate goal here isn't just to write papers about bismuth or give cool presentations. The ultimate goal is to build a zero-point energy device, and from there to unlock interstellar and eventually intergalactic travel. I know that I know how that sounds. I know it's audacious, but honestly, every major revolution in human history started with someone looking at existing evidence and asking, "What if we push this further?" Right? That's all I'm doing. So, and yeah, I don't want to do it alone. So here's what I bring to the table. I have capital. I have a unique perspective on possible solutions. I've spent years thinking about this framework and developing some interesting ideas. What I need are like-minded people with practical and experimental skills, people who can build the rigs, run the tests, measure the results, and help figure out what actually works. Well, if anything today resonated with you, if you felt that spark of this could be something real, please reach out. My email is on the screen, and Marat at goodnewsventures.com. I read every single message personally. And yeah, let's build what comes next. Thank you.
Marat, thank you. Thank you. I'll leave this up for just a second so people can write down your contact info and learn more about what you're doing. again, I am so excited that you were able to present this. As you mentioned, you do have more. You showed me, I think, 2 or 3 other slide decks, but this is the gateway drug, so to speak. And this is kind of the one that I thought, this is an amazing place to start. So let me do this. Before anything else, I'm going to bring our other folks in. I'm going to bring Drew and Chad in. Guys, let's put our hands together. You might have to give Drew a second. Let's put our hands together and give Marat an amazing applause. Thank you so much. Thank you. I'm super overjoyed. I'll leave you guys in for a bit. So we have a few minutes until Chad does his presentation. One thing if it's okay, one thing I wanted to mention was I did a little bit of research on this as well. Again, I've been hearing what you call this mythology about bismuth going back decades. The first place that I think it shows up is the Henry Wallace Kinemassic Force Field patent. That one I was not familiar with, but if folks want to look that up, I put that on the page. It was in the Philadelphia experiment. Most people don't know that. So Dr. James Coram and Jim Daring actually worked with, the fellow that wrote the Berlitz book on the Philadelphia experiment. While they were doing research on it, they found that the Eldridge, that class of battleship, they were trying to build those in such a hurry during World War II that the welds were having problems using lead. So apparently they started mixing bismuth in. So the welds on the hull were shot through with bismuth. That's kind of a little known fact that may or may not play a role there. And then, of course, bismuth is a key element in the ARTS parts purported UAP sample. And that's something I have seen, Jared Gates has been doing intensive analysis on it. That's a bismuth magnesium bilayer, multi-layer. And Marat, I don't know if this applies in any way to what you're saying, but one of the things that we found was we tried neutron activation analysis of that, where you basically expose it to intense radiation, and then you can measure the composition based on breakdown products. And Dr. Matthew Sadagas, he did the NAA for us. He was absolutely amazed. He said, this thing is an amazing radiation shield. He'd never seen anything like it. So there's just a few additional key points, I guess.
Yeah, exactly, because it's it resists the convergence, like it's the nature of the of the element. That's I always provide it, like when they say, well, why is so unique about bismuth? If you want to kind of tell someone who's not into science and don't really understand the specifics, I usually tell, well, if you watch the movie Dune, the spice, when there was like spice was used for what? For space travel. That's what basically bismuth is going to be used for. It's the material, that's the element going to be used in space travel because of its properties. That's basically the simple explanation for someone who is not versed into the science.
Now, I could be mistaken here, but if I remember correctly, it is also one group down from element 115, right? The fabled element from Bob Lazar's UFO lore. So yet another reference. I'll have to look at the periodic table. Okay, and I should welcome Dave and Michael Perrone as well. And Michael is actually a materials person. Michael, if it's okay, do you have anything else about bismuth? Do you have any other factoids about it?
Well, its nuclear spin is 9 halves nuclear spin, so that's unusually high nuclear spin to have, along with that all of that mass density there. Or sorry, is that the nuclear spin or is that the electronic spin? No, that's the nuclear spin. Yeah. Okay. But anyway, yeah. So actually, I was looking at Ken Wheeler's stuff because a lot of people were talking about how it's really smart stuff. I mean, he's so vague with a lot of the stuff he says. So I was curious, Marat, is there anywhere where he actually gets into detailed mathematics or something like that?
Well, he is quite a character. I can tell. So like it's really hard to to digest a lot of material. So what I've done is basically I download all the videos, all the materials. Nowadays with Notebook LM and transcription services, you can literally create a knowledge base, and you can chat with the material and kind of start your own research. There's not much, I guess, mathematics behind it, but it does make sense. I mean, like what I told, like all the geometries, all this, I guess, kind of the trace back to the golden ratio, the experiments with melting. I melted bismuth myself again into the cast, and it's all confirmed, right? So it does make sense. He's not a mathematician per se, so like I don't think that's his forte. So it's probably like maybe someone else has to kind of take this on and come up with some formulas if need be. But all the I guess properties of the material that they described, they're quite unique. I mean, if you combine them all and then you stack them against this theory, they all make sense because of the claims, right? So, and then again, I'm not trying to convince anyone in anything. It's like another lens from through which you can look at nature, right? And if this lens,
I should follow it up with I have looked thoroughly at his work, and there are parts of it that do make sense. So he talks about dielectricity as a part of magnetism, and that's something that Tesla and Steinmetz and Eric Dollard and people like that have mentioned. And so it seems like dielectricity, that's an electrostatic thing to most people. So what's interesting about that is well, actually, if you had like a time polarized component of the magnetic field. So you have magnetic field is a special relativistic thing. Well, when we go to general relativity, in principle, you could have a something oriented inward or outward, as roughly like what Ken Wheeler's talking about. And that object, you could consider it like a scalar term in 3 dimensions, but really it's sort of like a time-oriented vector. And that, if you consider slowing or increasing the rate of time in a specific location, that looks like you're changing the refractive index of the vacuum or the curvature. You're creating a gravity hill or a gravity well, whatever analogy you want to use. And so it's interesting to think of like, oh, actually, this additional relativistic component behaves more like an electrostatic phenomena, not a magnetic phenomena, but really it's part of magnetism. And so Eric Dollard and a lot of other folks, they put dielectricity in the same category as magnetism. And I suspect that that's why. So it's interesting to see.
You know what? Like I think the problem here, because he uses the dielectricity, which is like a bit of a misnomer, right? So I think his problem, because it took me a while, quite some time to understand the concept, and when it clicked, oh, now I got it. So, so basically, like he is. Coming from he literally what the the general relativity postulates. He is literally his theory is completely different. So and I guess I don't want to look like a fool right now. So maybe I'll prepare the next presentation and we can go over it. So I can kind of remove all the details and start with the kind of clean slate to try to rephrase, because he uses basically magnetism in the conventional way. When we use, we as in mainstream science, magnetism is something that attracts. So in his theory, magnetism is not that something attracts; it's something that creates space. It's just it's the radiative. So what radiates? If you look at magnetism via ferrocell, you will see those lines, right? So what radiates cannot attract. So that's a space creation. What actually attracts, it's the dielectricity, which not dielectricity in a conventional way. It's actually the electrostatic field that I'm talking about. It's the acceleration toward null point that created between two objects. If you have two powerful magnets, you look at them under the ferrocell, and you see they create a point non-specific between them where they both accelerate. So it's not magnetism. That's what he calls the electricity. So that's why it's confusing. So magnetism is not magnetism in his theory. The magnetism effect produced by the field that he called dielectricity, which is technically electrostatic field that accelerate toward the null point between the two objects. So that's where confusion comes, right? And then the third part is the electricity. So this is the tripartite system where electricity, magnetism, and dielectricity, so to speak, work together. But again, I need to rephrase it so it's easily understandable, because I know it's confusing. Because when I tried to understand this model, I was like, I didn't get it, because he used the term magnetism in a completely different. So he basically, once you learn the magnetism, what attracts. So it's really hard to rewire your brain. So it does not attract. Magnetism creates space. It's the radiative force. What attracts is the acceleration toward the null points of, from. So anyway, so I don't want to kind of ramble anymore on that. I think, if there is interest, I can come up with, another presentation and maybe, go over those. I will try to translate them, quote unquote, so to speak, to that is easily understandable, and then provide some actual experiments that confirm certain things, right? And then
yeah, that sounds good. I think I don't know. I don't know about Ken Wheeler's model per se. I do know that if the magnetic field is part of dielectricity, in a sense, you could think of magnetic forces as some sort of non-metricity or a torsion-based like topological phenomenon in space, where the different pieces see different space times. It kind of relates to something called Brand's-Dickey theory. And there's an additional model from that where you have two. You end up having two metrics for space time. The bimetric model. There's a few of those. But in any case, what Tesla and Dollard, I think, were talking about, I think, is something different than Ken Wheeler for dielectricity. So you have a magnetism and you have electricity. And dielectricity specifically, when you really look into what Tesla was talking about, he would talk about these devices emitting like a pressure force. You could feel it with your hand or whatever object you brought near the thing. And that pressure force actually relates to this dielectricity. So if you actually have thin bands of space-time that has a different refractive index moving outward with the speed of light, that is actually going to put a pressure on a dielectric or any wave in that medium. It's going to try to move it away from the center of that. That's a parametric effect, not directly due to the field gradients. But
Michael,
we could go on.
Well, if I could jump in for a moment, and this would go maybe to yourself, but definitely to Marat as well. Marat, you had talked about proposing some experiments, and if you'd like to bring those back on in the future and just outline, like, hey, this is what should be tried, and this is what you might be looking for when you try it, and this is what I think may happen. I think that would be wonderful, because it might give people some guardrails for paths.
Exactly. I mean, we can debate all day long, regarding a theory, like who's right, who's wrong, and then there's obviously there's But I think the more practical approach is just run experiments, and I think I was fascinated because of some theory that I look at it confirmed that it works, right? So why not try to bigger scale experiments and. That's what I said. If anyone is interested in doing more experiments, and that's I want to put capital to work, and I think that's one of the, the biggest I think it's possible, literally. Like it is just a matter of figuring out.
I think it's possible to. I think it's important to do experiments, but also we have to be thinking about how these models limit to the ordinary physics in some limit case. So, like, the structure of the model could be predictive, but it could be different enough from existing physics that you won't be able to really fit it in with the rest of stuff.
Yeah.
And that's a challenge that
I've got
creates
an
more
idea for a
challenges
test.
later.
I've got an idea for a test.
Yeah, go for it.
Right now, I've got an operational electrostatic pressure engine, and we're basing it on aluminum and maybe titanium, because I don't really know what the very first layer of this factory aluminization is. I think it's titanium. So if I were to swap out and put bismuth in place of the, we'll just say it's aluminum, do you think I would somehow magically make more thrust? Because right now I'm just using electrostatic pressure against the aluminum.
It'd be worth the test. It'd be worth the test.
It will depend on the charges on the plates.
Drew, titanium oxide, by the way, is a high K dielectric.
Yeah, I don't know that it's titanium oxide. I think they sputter it commercially. When you buy commercially metallized polymers, I think they sputter titanium, vapor deposition titanium onto the polymer, and then they do a chemical plating to put the rest of the metal on there. So the very first atoms that are going to be seen by the field are going to be probably titanium, but either way, they're either titanium or aluminum. And I can run any experiment, but what I'm saying is there any difference between aluminum and bismuth when it comes to electrostatic pressure? I mean,
I've given this some thought actually before. The concentration of electrons is lower, if that matters to the pressure force. But at the same time, the nuclear effect would be larger because the nuclear spin is much larger. It's 9 halves instead of 3 halves.
Yeah,
So,
but the nuclear spin is not related. That only comes into effect when you have a magnetic field present, which he doesn't.
not necessarily. So he's been working with negative charges to get forces, and avoiding positive charges because he didn't see anything before.
The negative charges are on one side, but the positive, on the other side is going to be obviously the opposite. It's going to be a positive charge.
Sure.
There's no current running through it.
There's no current.
Right. So the spins, the 3 halves or 9 halves that he's talking about are only noticeable when there's a magnetic field, which kind of brings to what I'm working on.
Yeah. Well, guys, let's
Not necessarily.
We're at the top of the hour. Oh, there's Dan. So,
hey, Dan.
So if it's okay, why don't we, Marat? I would love to have you back, and we could go over this more. And if you want, we could do kind of an in-depth Q&A session too. You know, and again, our conference will go all day. But.
Yeah, I think it's probably I would be interested in maybe doing another presentation on the kind of different way of looking at the field modalities, how this field modalities interact. I'm probably going to wrap a lot of people the wrong way, which is fine. But I think it's more important to provide a different perspective. And once this picture kind of because it's completely different from the mainstream, right? And again, we've been wrong. Again, we as a humanity back in the Ptolemy and Copernicus, when we had navigation, Earth-centric, so everything works, right? We had the compasses that if you guys remember those globus with concentric circles around it, they used for navigation. Everything worked, right? And then the guy came, I think we all wrong here, right? So could be an interesting angle. And with that theory, literally intergalactic travel is possible, which is probably with the current model is impossible. Just the time itself, it's like it's almost impossible to get there, above the speed of light, and but this theory actually allows that, and that's what really makes me exciting, because expanding beyond our own universe is not a science fiction anymore, and I know it. Like if anything I'm good at is getting to the bottom of things, right? And I think I've done a pretty good job. Although I'm not scientist by but I'm pretty good at figuring out stuff that kind of if it works or not. So I'll let you to be the judge. Next time I'll provide the kind of simplified version. So adapt it so it's easily understandable, and then and again, I'm looking for like-minded people to make it happen.
Wonderful. Well, Marat, thank you again. We are at the top of the hour, so guys, let's do this. Let's put our hands together one more time and give an enormous applause for Marat. Thank you so much. Thank you so much. I would love to have you back. You have more that you're talking about on Bismuth, have more on other models as well. So since we're 2 minutes past, so what I'm going to do is take everybody out of the studio except for Chad and Dave Palachuk. So Chad, welcome, sir. You were going to do a screen share, I think, and that's because you have videos in your PowerPoint. And I'm happy to walk you through that if you need help. And so yourself and Dave, you've both you just published a peer-reviewed paper on dark operational warp drives. You've spoken before on basically, for lack of a better word, UAP or UFO warp drives. And we've done several podcasts on this as well. I am absolutely in love with the model you guys have developed. I think that this is the biggest thing in UAP in several decades. That's not an understatement. So,
thanks, Tim.
Thanks, Tim.
Excuse me. Yeah,
really appreciate that.
Yeah. Well, so to do a screen share, if you click down at the bottom of your browser window, there's a plus button, and then there should be a share screen. There's a little pop-up, and it should have share screen, and then it'll say Chrome tab, window, or entire screen.
Okay, I see it here. Yep, I'm going to share my screen.
Okay.
Chad, you need to increase your microphone a little bit. It's
okay.
Pretty quiet.
Okay, there we go.
There we go. Hey, just before we get going, that was an incredible discussion on Bismuth, and I understand everything behind it, but I'm surprised we're not using it to do like data storage because of its properties. And I think Drew should try to see if he can do vapor deposition of bismuth onto his plates and understand that. We have another gentleman who approached us about what he's doing to somewhere down in the U.S., and he was asking us questions. But I think it's, everybody's saying, well, it's not the rotational speed. I don't believe that is. I believe that was wrong. He needs to do the experiment.
Okay.
So,
well,
anyway.
guys, let me do this. Chad, since you have it up, I think you're all set to begin. I'll leave both of you gentlemen unmuted, and I will be here in the background, but thank you again. It is not an understatement to say the work that you guys are doing. I could make a good case for this. This takes UFOs out of being observational and makes it a predictive science.
So Tim, before Chad gets started, I'm going to mute and let Chad run this whole thing, because we've taken this a little further. We've taken our information. We want to present something totally different that I think you're going to enjoy, and everybody's going to enjoy who's watching it. And that's just, how do we prove? Because the word proof is so impossible to do in the scientific method that we've come up with, different methods. We're engineers, and Chad's going to show you today why we did what we did. And I'm going to mute my mic now and let Chad take it.
Okay. Wonderful. Thank you again. And I will mute myself, take myself out, but I will be here if you need me.
Okay, I've adjusted my microphone. Do I sound better? Perfect. Okay, I'm going to present a short little video.
For decades, the study of UAP has been plagued by a single problem: uncalibrated data, anecdotal sightings, and blurry photos have led to dead ends and easy dismissals. But what happens when you treat that outlier data not as a dismissal, but as a forensic clue? What happens when you apply decades of engineering experience to the problem? Engineers volunteering with CSSAA analyzed several historic photos and recent videos. One stood out, the Ridoy video. Through forensically sound frame-by-frame reconstruction and post-capture calibration using fixed reference points, the video was turned into hard scientific data. A surprising discovery was made which changes everything. The object visibly demonstrated a previously unknown telltale atmospheric disturbance. For the first time in human history, an Alcubierre warp bubble in action has been visibly revealed by a leading-edge vapor cone, one of the 5 new observables. This finding is not predicted by any known human propulsion system, but instead is an exact one-to-one observational match to the mathematically predicted spatial compression required by theoretical physics. The conclusion is both uncomfortable and unavoidable. The Ridoy video captured an Alcubierre warp drive vehicle showing 3 of the original observables and all 5 of the new observables.
Okay, let's try to go to the next
Decades.
There we go. Sorry about that. Okay, so Dave and I are volunteers with the Center for the Scientific Study of Atmospheric Anomalies. A little bit of housekeeping information here. Our employers require this. The information presented in this presentation is solely the opinion of the presenter and does not represent any opinion of past or current employers. Note fair use notice for some photos, artwork, and video clips for educational purposes. No information presented in this presentation was derived from classified materials supplied or disclosed to us. Links are provided at the bottom of the slides. So this started with a book called Hidden in Plain Sight. This is the layman's version, and we took this book and produced a peer-reviewed paper about 1/3 of the length of the book. So from the engineering's point of view, the scientist question, defining the domain. In academics, academics investigate the space. They focus on the why. The goal is to discover fundamental laws and origins, perspective, anomaly as a curiosity, and ethics is a voluntary peer consensus. In engineering, we are applied physicists. We are still scientists, but from a slightly different point of view. Ours is the solution space. We focus on the how, not the why. The goal is to apply laws of physics to solve problems and design systems. Perspective, in the case of anomalies, we view these as risks and variables, not a curiosity. In ethics, we have a statutory duty for public safety. And when we speak about ethics in engineering, we're not talking about not just don't participate in industrial espionage. We're actually talking about the scientific method is written into the engineering laws so that we are forced to follow them whether we like it or not. So why is this important? Let's use an example from history. This is from this is actually very close to where I grew up. It was Iron Workers Memorial Bridge and a collapse that occurred in 1958. As a case study for forensic failure, the incident occurred during construction in Vancouver. 2 spans of this bridge collapsed into the Burrard Inlet. The cause? A junior engineer performed an incorrect calculation for temporary knee braces. He failed to account for the buckling load. People told him, "This doesn't look right." And he responded with, "I'm the engineer in charge. It's up to me to decide. And if I say it's going to work, it's going to work." Well, the toll, 79 workers fell into the water. 19 of those people died. Of the 19 people who died, that includes the junior engineer and his superior who failed to overlook this error. He managed to kill himself in this event. Now, the lesson, the standard of care is absolute. It doesn't matter if you're a skeptical or confident. If the math is wrong, the structure fails. Duty to oversight. Senior engineer's failure to catch the junior's mistake was a breach of his statutory duty as well. Applied physics versus theory. In a lab, when a wrong calculation happens, it's a learning moment. In the field, when a wrong calculation happens, it's a casualty event. Now, the interesting part about this event that I did not write down, but when this event happened, the local police were getting phone call after phone calls telling them that the bridge had collapsed, and they didn't believe it. They're like, no, that's not possible. It was the 10th phone call when it started to dawn on them that it actually might be true. And at that point, they started to react. So why is this important? Why are we bringing up engineering rules in the case of studying UAP? Well, on the right-hand side is a famous example of a recent video from, I believe, over Colombia. And this interesting UAP basically played a game of chicken with the aircraft and buzzed it well within the 500-foot rule. Now, in aviation safety, any near miss is something that occurs underneath or inside of 500 feet. This changes the game. This is no longer a curiosity, an anomaly. This now becomes a legal incident in which engineering rules start applying. So in engineering, safety comes first above all other considerations. The statutory reality is it's not a suggestion or of a personal value. It is the first canon of the national safety or national standard professional engineering in every provincial engineering body. Priority of truth. If a conflict arises between academic consensus and public safety, the engineer is legally mandated to choose safety. Forensic consequence. Ignoring anomalous data like UAP aircraft near misses isn't being a skeptic. It's a failure to identify potential threat to life and property. So the accountability gap. Academics, it's voluntary. All of these rules, scientific rules, they're voluntary. They can choose to follow them, and there's no real consequence if they don't. Priority is consensus and publication. Consequence, a retraction in a journal. For a professional engineer, it's much different. The codes are very clear. Violations equals loss of your license, loss of your career, or financial penalties if it's an infraction. Priority, public safety, and risk mitigation. Consequences, for the example presented was 17 dead workers, 17 dead construction workers and 2 dead engineers. Now, engineering ethics codified in law. Legal accountability. Academics face retractions. Engineers face liability. Ignoring pilot sensor data isn't a difference of opinion, it's a professional negligence. Duty to warn. Scientists wait for consensus. Engineers act on statutory duty. We cannot wait 10 years for a paper when a glitch represents a current kinetic flight hazard. Root cause analysis. Academics ignore unknowns. Engineers solve for variables. An unidentified object in a safety critical system is a risk that requires immediate root cause analysis. We've all watched Ryan Graves talk about flight safety. Well, he's also an engineer. He's compelled by these rules to act out and tell the world we have a safety issue in our skies. And if he doesn't, eventually it could come home and to roost and ruin his career. So he's acting out because that's what he has to do. So rogue waves. This is a historical parallel to UAP research. And it may seem out of place for a minute, but we'll get there and you'll understand. So the MS Muchen was a ship that was sunk in 1978. The case study, 28 souls were lost. The incident, state-of-the-art German Lash carrier, vanished in the Atlantic. What they discovered, they found the lifeboats floating. No one was on board of these lifeboats. They were actually ripped from the vessel by extreme force. They were 20 meters above the waterline. These lifeboats were stored at the highest possible position around the bridge at between 24 and 30 meters, or 80 to 100 feet. Now, another event that happened even further back in time, I should rephrase something here. When this was discovered, the reaction of the oceanographers was, well, this was a once-in-a-lifetime event. We don't have any other records of anything else. Our math says this was a 1 in 10,000 year storm wave. Therefore, we don't have to worry about it again. That was their conclusion. But there were lots of other anecdotal events that had happened. So the Queen Mary in 1942 was transporting 16,000 troops when it was struck by a 92-foot wave broadside. Near catastrophe. It rolled over to 52 degrees, often cited as 37, but the analysis showed it was 52. If she had listed just 3 more degrees, it would have capsized. The result, despite the harrowing expert testimony from the crew of one of the world's most famous liners, the scientific community continued to treat the rogue waves as mariners' myths. They must have been drunk. So, photographic evidence. Just as in UAPs, there's photographic evidence of rogue waves. Here's a photo from a supertanker by Esso, or an Esso supertanker. This was a 100-foot wave, and you can see on the right the tugboats in that right photo to scale that shows you how big, how tall this boat or this vessel really was. Now, the price of denial. Investigators rejected the rogue wave theory because science said it didn't exist. They blamed unsecure hatches or human error or something else. The result, because the experts' testimony of surviving sailors from other ships was ignored, the industry made no changes to ship design for another 20 years. This one here is a Norwegian tanker struck, I believe, off of South Africa, and you can see the bow was torn clear off. The event that changed it was the Dropner wave. In this case study, the paradigm for 100 years since science claimed waves higher than 15 meters were mathematically impossible and a sailor's myth. However, January 1st, 1995, a downward pointing laser on the Dropner oil platform measured a record-setting 25.6 meter wave. I have an AI. I took a night photo of the Dropner platform and I applied a wave to this. That wave is to scale. It is an 89-foot wave that cleared the underside of the superstructure by mere feet. So this was a forensic shift. This no longer was a glitch. Scientists said, okay, this is real. We've made a mistake. And the lesson was extreme data isn't a mistake just because your current model can't explain it. They employed a European satellite, and they found that, in fact, at any given time, there are 3 rogue waves existing on the planet. And now, because of that discovery, the building code vessels have changed, making them safer. So what if engineering ethics had been applied and had been employed by the oceanographers at the time when the Munich discovery happened? Well, let's flip the script. The validation of anecdotal evidence, had the engineer's ethics been applied, the mythical reports from sailors would have been treated as expert human-censored data. The integrity of the steel, bent pins on the lifeboat would have been treated as forensic pressure gauge, calculating the force required to bend those pins. The ethical outcome, the mandatory warning, a duty to warn would have been issued to the global fleet regarding extreme wave hazards. Design changes would have occurred. Ship hulls, superstructures would have been reinforced decades earlier, and lives would have been saved. because of oceanographers debunking and ego-driven, oh, our math is right, we can't think of any other math that can explain this, therefore we're right, lives were lost. So how does this apply in the UAP context? Well, let's take the JAL 1628 example. In this particular case, the event happened. The captain reported a massive craft over Alaska. The data, it wasn't just lights he saw. There was onboard radar, FAA ground radar, 2 locations, Anchorage and Elmendorf, recorded the UAP alongside or along with the 747. And in the parallel, despite 31 minutes of multi-sensor tracking, the FAA and academics dismissed this as a weather or some kind of glitch. And someone even said that it was, they spotted misconstrued Jupiter. And I like to say, yeah, they saw Jupiter being magnified through a weather balloon, and therefore it looked much larger than it really was. Safety hazard. The captain was flying a 747 with cargo. If an object pacing a 747 and performing high kinetic maneuvers, this is a safety of flight issue, regardless of what it is. They reported turbulence when it got close. They reported feeling heat when it got close. This was a very serious safety issue happening in the moment. And it doesn't matter what skeptics say after the fact. What's important is what's happening in the moment now. How do you react to it? How do you keep your aircraft and your passengers safe? So, flight safety and the statutory duty to warn. Pilots are expert sensors. In engineering, a pilot's report is not a story. It is a human-in-the-loop telemetry. The first can and hold paramount the safety, health, and welfare to the public. If an object is in the path of a stolen aircraft, its origin, ET, China, glitch, is irrelevant, doesn't matter. Its presence is the forensic fact. To dismiss this presence after the fact because the origin is impossible is a violation of the standard of care. What does it matter how the pilots, what matters is how the pilots react in the moment, not after the fact conclusions. Going back to this near miss video, making a scientific sounding public statement without doing any research is a failure to do your due diligence. This is where the engineering laws come into effect. Like I said, this is the scientific method written down in legal form for engineers to follow. It is voluntary for academics and debunkers, but it is still written down, and these are the rules that have to apply in this particular case, or in this very specific type of cases. Another issue, practicing outside of your area of competence. Astronomers and software programmers giving technical advice on complex instrumentation systems for which they have not been trained. In engineering, you're not allowed to make a public statement or a design decision on something you have not been trained in. And training doesn't just mean going to school for 10 years. Training also includes on-the-job training by an experienced professional in that type of discipline. The breach of data, throwing out recorded instrumentation readings and discarding expert witness testimony must be treated as human-in-the-loop telemetry. Pilots are considered expert sensors. So when someone says, you know, the Tic Tac guy said there was a fleet of them on the radar, and that person says, well, that's anecdotal, I'm not going to include that. That's actually a breach of data under engineering ethics rules. So disregard for aviation safety standards, failing to acknowledge that any identified object within 500 feet of an aircraft is, by FAA definition, a near mid collision. To dismiss such an event is as insignificant because the object's origin is unknown as a failure to recognize a presence of a legal hazard. It doesn't matter what it is. Matter of fact, in engineering, we have to assume worst case scenarios and the most conservative possible. And in this case, the most conservative possible explanation is this is a Chinese or Russian aircraft using some advanced propulsion system playing chicken with civilian pilots. That is how in engineering we have to view this. We don't go, it's an ET, it must be a foreign tech. And therefore we have to treat it as a real object. And it doesn't matter how it is propelled. To us, it is a real object propelled by somebody who is human. We can argue later about NHI, but under engineering rules, that is the assumption we must take. All right, so system failure, human factors in engineering and negligence. And I'll use construction as an example. In construction, there's this machoism variable. You don't want to appear weak or unskilled. So there's this pressure to not use safety equipment or not use it appropriately. You don't want to look like you're a weak-ass person. It's a standard of care leading to preventable fatalities. And then there's maintenance laziness variable. Safety systems like machine guarding are frequently bypassed because they are perceived as an inconvenience to the workflow. So one manager I dealt with stated, we removed the guards because it was too much effort for maintenance. This is the definition of professional malpractice. Now, how does this work in the UAP? For 70 years, there has been investigative sabotage. Decades of social debunking have created a hostile reporting environment that bypasses FAA Order 8020.11. Pilots are functionally intimidated into a non-compliance. When they think the object was a UAP, they fear for their flight medicals, their professional reputations, and more than that, they fear the 500-foot incursion. Origin doesn't matter, but that fear overrides everything. By compromising the mandatory reporting of near misses, obstructive skepticism has effectively blinded the FAA to systematic kinematic risks in our airspace. So if these were Chinese or Russian vehicles, this debunking has effectively allowed our foreign adversaries free reign of the skies. Now, there's another, and this is my other favorite topic I like to do with when academics were proven wrong. And it was the Clovis first dogma. They argued that 13,000 years ago was the earliest that people could have come to North America. And any findings that prove otherwise are anomalous or bad science. And they demanded a dead body or a settlement that they refused, and they refused to look at them. So the White Sands discovery in 2021 was the changing game. It was fossilized footprints found in New Mexico dating back to 21,000 to 23,000 years. The lesson, a footprint is not a theory, it is a forensic trace of a physical presence. You don't need the person standing there to know they walked across the mud. The application, the forensic math presented in our paper of historic UAP photos in the recent 2023 Redout video isn't a UFO theory. As you will see, these events are forensic footprints in the sky. And what I like to emphasize here is that the academics, they fought vicious verbal battles over when did man come to North America. There was no society risk. There was, when it was discovered, everyone went, oh, that's interesting. But it didn't matter. It was people's egos and people's reputations that they felt were on the line if they if they changed their mind about when man came. There was no risk. So why are they arguing? Why the fighting? It was just nonsense. So
Chad, I think your volume is dropping a little bit. Okay, sorry about that.
Okay, is that better?
Yeah.
Switch your microphone more to face you, Chad. It keeps fading in and out. I think maybe your headset would have been better. But anyways, is your microphone pointed right at you?
Yeah, it's like 3 inches in front of my mouth.
Well, it's weird.
Yeah, it's better now.
Okay, good. I must have been moving away. All right, so footprints in the sky. So here we have the 5 observables as released by Luis Elizondo and the scientific people working with him. These are the first 5 footprints. We found 5 additional observables, 5 additional footprints, as you can say. Gravitational lensing. This is where objects in the background are appearing to be distorted as a UAP passes in front of them, or the UAP structure itself is being distorted. Leading edge vapor cones. This is the new discovery that we presented in the paper. And this is where in the spatial compression area in front of or above a UAP, it creates a vapor cloud. And we'll go into that a little bit later. Fast and slow oscillation. What we discovered was an oscillation turning the warp drive on and off approximately 30 times a second as a flight visual aid system. And then pronounced disk tilt to counteract Earth's gravity and move forward at a slow speed. A UAP must tilt its warp system slightly, say 4 to 7 degrees, to counter Earth's gravity and provide a slow forward momentum. And then the last one was saucer-like skipping motion. So technical background. We need to get into some information here so that we can explain what's going on. All right, so the Alcubierre shape function, as shown in the lower left, that's the formula. And then this is a scatter plot based on that formula plugged into an Excel spreadsheet. And it takes this formula, you put a point of space in, run it through the formula, and that'll tell you how far the point of space gets pushed away from the center of the warp drive, or conversely on top or in front gets pulled towards the warp center of warp drive. And you can see there's this weird discontinued split down the middle. And then there's a downward pointing V in both cases. And I'll explain why that's important in a second. Now, the Alcubierre diagrams, here's a couple examples, is showing a flat center, but this isn't quite right. But let's go into what is gravity and how does it work. The best way to describe it is take a block of wood, drill 2 holes through it, thread some string through it, tie that string to a doorknob, and then pull the 2 pieces of string apart, and that doorknob or that piece of wood will move away from you and towards the doorknob. In this case, the doorknob represents a massive body like the Earth. The wood block represents objects on the Earth, and then the string represents the spatial fabric that's being pulled apart by the mass of the planet. And it acts like a lever effect, where every molecule in your body is simultaneously pushed downwards towards the planet. Now, how and why is this important? What we did was there was a paper that requested and talked about how the Alcubierre had this split down the middle, and there needed to be some kind of Gaussian elastic formula that would connect the 2 hemispheres. And we found that. I went through 3 or 4 different elastic formulas until I found the one here. And what you get is this wine decanter shape, where you have a large bulbous expansion below and a tight contraction above, and this narrow neck where a vehicle can safely exist inside the neck and experience the same gravitational acceleration throughout. And it happens to be a narrow disc-shaped portion of the neck. Now, this works beautifully for countering Earth's gravity. And it's no mistake, no accident that UAP are disc-shaped. It wasn't artistic. It wasn't Hollywood. Hollywood followed what was seen in the sky, not the other way around. So the next part, we took this formula and we ran it through a compression methodology within Excel and put out this color-coded compression spatial plot. And you can see here the magenta here is 1% of normal space, so that's how much it's compressed by, just above the UAP or just above the warp drive. And down here, it's actually 2.5 times, so it's a very large expansion. And this magenta part, this is the key part that we are going into. Now, I did email these Excel spreadsheets to Tim. If anyone wants to go through them, look at the math, please reach out to Tim. He can send you those Excel spreadsheets. So forensic fingerprints. This little magenta blob in the middle is a forensic fingerprint. And in the Ridoy video, which was a 2022 or 2023 video that was shared on TikTok, we discovered in the last 2 frames, as the vehicle was zipping off at a high rate of speed, a white cloud in front of it. And this was a complete shock to us. When I saw this, I thought, there's a cloud expanding there. And because I worked in HVAC, I know about adiabatic cooling. And I realized this is an example of adiabatic cooling. And the interesting part here is this cloud is actually revealing the shape of the warp bubble containing the vehicle that's within it. So how does this work? Why is that spatial contraction creating this warp or this vapor cloud? Well, let's use the TARDIS as an example. So you have this 200 square foot box that's containing a 10,000 cubic foot interior. When air comes in, it's going to suddenly find itself in a much larger volume, and it's going to decompress rapidly. With adiabatic cooling, when it decompresses, it cools rapidly. Any moisture in that air will condense and form a vapor cloud. So the example on the left shows as it's countering Earth's gravity and moving forward slightly, there's going to be a cloud that forms because it's moving through the wind. If the cloud lasts long enough, you'll see a trailing vapor that could be up to 2 or 3 diameters of the vehicle itself. And on the right is another example of adiabatic cooling, but in jet aircraft, when they reach 0.8 to 1.2 Mach, this vapor cloud forms. It's the same sort of thing, but instead of being behind it, it's in front of it. Now, here we have the Alcubierre warp bubble being overlaid, or actually underlaid, underneath the. So what I did here is I took this second to last image, I overlaid a disk to represent it, and then I underlaid the warp bubble spatial color plot, and I angled it to match the screenshot. And what you see on the right with the animation as it switches back and forth is that vapor cloud is an identical one-to-one correlation to the magenta plot, showing that revealing really that is the warp bubble, the most spatially compressed part of the warp bubble being revealed in this image. So one thing I'd like to point out, Dr. Gary Nolan has said repeatedly in several of his podcasts and interviews and presentations, in science, you truly can't prove anything unless you can prove it with math. Well, we're showing our math here. This is not an artistic rendition. This is a math plot. So in engineering, we call this a unique geometric signature. It's like a 15-point exact matching fingerprint. This is not what a lot of people are used to seeing for evidence, but this is still evidence. It's mathematical evidence, and it's what we call deterministic proof of identity. a physical stamp in the clouds. Make no mistake, just as frost clouds proves a leaking propane tank, this vapor fingerprint also proves the presence of an Alcubierre warp metric. Now, this has a historic example. In 1919, Eddington went down to the southern hemisphere to take photos of an eclipse to see if Einstein was right about light being bent by a massive object. What he discovered in the photograph was the stars were indeed farther away from the sun than they should have been. Before Einstein's paper, no one knew that gravity would bend light. In that same way, no one knew that a UAP should show or could show a leading edge vapor cone. The radioid video falls under that same weight of evidentiary examples. It's the same type. It's the first time this has been seen, just like the Eddington photo was the first time lensing was seen. Now, some people might say, well, maybe it was a feature of the landscape. So I've put the three images side by side so you can clearly see that vapor cloud was not a feature of the landscape. So could this be a CGI explanation? How would a hoaxer have known to create this leading edge vapor cone? It's not physically attached. It's not over top of the object. In CGI, when you use a lens flare, it's always on top, and there's only a few, I think about 8 or 9 standard lens flare algorithms that are used to create them visually, and this doesn't match any of them. To me, a hoaxer had to have come back in time to create the hoax, to pull a prank on our work. It doesn't make sense. There's no plausible hoax explanation for this little piece. So, additional observations. The Rex Heflin photos is actually the earliest form or photo of a form of the vapor cloud. The fourth photo, the object disappeared and took off at a high rate of speed and left behind a vapor ring that was in photo number 4, D, item bottom right. And the object might actually still be in the photo top left, circled in red. What we believe happened here was, as it departed rapidly, it created a vapor cone in front, but then went through the vapor cone, splitting it, creating this ring-shaped cloud that lasted for a few moments afterwards. Now, the Aguadilla case also showed a potential vapor cone. Here in the center, above left is, and I've color-coded it so that it's clear. Blue is cold, red is white. Above left, as it's traveling from right to left, is a vapor cloud. And on the left-hand side, items A through C show a trailing cloud that existed long enough to stretch out. And on the right, E and F, it showed center, which indicates that it was counteracting Earth's gravity, but using its forward momentum to continue on. And then interestingly, lower right here, you can see the background building was actually bending underneath, indicating a gravitational lensing event as well as the vapor cloud. So Skywatcher, when they first announced their work, they actually released 3 photos, or still images, 2 are presented here, showing a vapor cloud over top and to the right. Now, they said there appears to be some kind of cloud or vapor around, as if worn like a hat. And they said they knew why, but they still haven't publicly published anything about why. And there was another release in 2025 from a video taken in Perth, Australia. And you can see here, the vapor cloud is trailing behind, but forming in front of as it's moving through. And then the Tedesco brothers released late last year with one of their own videos showing an orange glowing UAP creating a trailing vapor cloud. Well, let's press play on that. So you can see it here, and it's kind of tumbling as well. Okay, so gravitational lensing. What is it? Some people here will know, but basically what happens is a large body in space bends space in towards itself, creating a lens. So that in this case, a quasar far away, that light bends back towards the Earth, and what we see on the right-hand side is a ring, and the center of that quasar is actually seen in four locations. So here is an example, a real-world example, where I've taken two coins, placed them on top of a cup, and I'm placed it in front of some gingerbread houses to represent what is gravitational lensing. So as the camera moves around, you can see the background objects are being distorted by the cup, which represents our Alcubierre spatial warp metric. But it's not just underneath that's being affected. Now here I've placed the two coins inside, and so not only is the background being changed, but the appearance of the coins themselves also get changed by the lensing effect of the warp bubble. So UAP gravitational lensing, this is a diagram. I've taken the scatter plot, placed a dark cube in front of it, and you can see here how that spatial warp would affect the light passing above and below it, which will bend it back down towards an observer at a distance. And to that observer, this dark cube would appear to be inside a clear round sphere. On the right-hand side, lower right, is a animation that is easily found online of a black hole as it moves across a background galaxy. And you can see that background galaxy being warped dramatically by the presence of the black hole. Now, for us, the aha moment happened with another video captured over Colombia as well. This is two animated GIFs that highlight it. As it moves in front of the background clouds, those background clouds move, and they move severely. And interestingly, they only move in every other still frame. So this is slowed down so you can see each individual still frame as it's passing by in front. And if you look at the clouds away, over here and over here, or down here, they move very minutely, whereas right behind the UAP, they move severely, which indicates that the change in the clouds is occurring because of the presence of the UAP, not because of the window pane that the video camera is capturing the light through. So forensic analysis. The scientific investigation of unidentified anomalous anomalies is severely hindered by inadequate data collection and a lack of robust data. Current data, often collected by instruments not calibrated for scientific purposes, are fragmented, unsystematic, and lack sufficient metadata. This is a quote from Wesley Waters, the lead author for the Galileo Project paper published in 2023. This part of the quote is often used to state civilian photos and videos are uncalibrated and therefore scientific garbage. However, and that's my editorial adjustment or addition here, he continued on and wrote, civilian reports often contain statistical outliers that resist conventional explanation, potential scientific anomalies worth retrospective analysis, and the design of new forensic tools. So he did say there is very interesting stuff out there that should be evaluated, but his first paragraph is being misquoted. So in the scientific method, in science, when the data doesn't match your theory, the theory is wrong. However, the misquotes, here's several examples. Existing data often fragmented, uncalibrated, missing critical metadata, has led to the current data collection efforts about UAPs are unsystematic and fragmented, often using instruments uncalibrated for scientific purposes. This is a Facebook post. Here's another one from Reddit. Walters Galileo says uncalibrated civilian videos are trash data, so why bother? Someone else said on YouTube, most UAP clips are from uncalibrated phones, straight up unusable for analysis. And PBS News said skeptics point to Waters' work. Civilian footage is uncalibrated, low res, and metadata free, rendering it scientifically unusable. I've had someone, an academic, actually state this last one, quoted it to me about my paper. So let's go to the next part of this, the unscientific method. When the data doesn't match your theory, something is wrong with the data. This is how debunkers work. They don't mean to, they don't realize they are, but they are. So what is calibration and how does it impact photos and videos? Well, let's take this photo of a comet. This was taken by an amateur photographer, astronomer, through an uncalibrated telescope using an uncalibrated camera. Does this mean the comet did not exist? Of course not. It existed. What it means is you can't use it to get precise measurement accuracy. Now, NTSB has rules and procedures written up for calibrating, post-calibrating photographs and video segments. And this example from last year, the fatal UPS crash, is a prime example. Forensic engineering does not throw out outlier videos. We treat them as the most valuable evidence we have because we can post-calibrate them and turn the blurry civilian footage into hard data. This is what we're doing. This photo, or this still frame, shows the jet engine as it's being torn off the wing before it erupts into flames. This is what we're looking for. We're looking for these minute little adjustments in the video or in the still photos that show something is misaligned and out of place. Now, this is a quote from the NTSB. In forensic science, post-record and calibration using a known reference object is standard practice in accident investigation is routinely relied upon by the NTSB as critical evidence in major crash investigations. Engineering has adopted this methodology and is also used extremely frequently. So in engineering, we use post-calibration on a daily basis. Not once in a while, not once a month, not once a year, very daily. We can receive tens of thousands of photos from the clients, from our colleagues, from site workers. And so we have established methodologies to take these photos and calibrate them to use them mostly in as-built type situation. And it's advanced now where you can see here on the right, there's a backpack with a 360 camera. This happens all the time. There's site walkthroughs with these types of cameras to record what was constructed. And we use that to then, we used to get what we call black lines, drawings saying, oh, we installed this thing here instead of here. Now we get photos and we have to adjust our models using the photos. And then for sites, drones are now used at every site. I have a coworker who came up to me a couple of months ago and said, I've got to do a electrical plug-in for a remote work site for a parking lot, but all they did is gave me all these photos from a drone. How do I work with this? So I had to show the person how you calibrate it in CAD to create the drawing from the photos. Dave, you have a really good example. A couple examples.
Yeah, we get photos all the time in my business, which is doing security systems, very high-end security systems. And then basically it's the same idea. Chad, we get photos, and from that photo we can calibrate. And we take a known object that we see in the photograph and end up calibrating the entire scene. The last example I had was the side of a building with a known sign on it regarding trespassing and video surveillance in effect. We know the size of the sign because we produced it. So from that, we calculated everything, and then we set the camera angles and stuff. And before I continue on, there's nothing else I actually want to add. We've only got about 1 or 2 minutes, or we'll run out of time for questions.
Okay.
So we have to speed up a little bit.
Okay, gotcha.
All right, thanks.
All right, thanks. All right, so scientists calibrate beforehand, taking a picture of a known object. Engineers will take measurements of a known object in a photographic scene, and we have multiple software programs that allow us to calibrate it. Here's the example of a calibrated model using telephone poles. That's important because the Rex Heflin photo was calibrated using telephone poles in the exact same method. So in our forensic reconstruction, just like police use sticks to identify how bullets went through an object, we use three-dimensional lines to represent how the light was traveling. Rex Heflin was interesting. The third photo, you can see the object twice, and what it was it was turned on and turned off and captured in the single photograph. You can see it in green on the left and red on the right. E shows the object perfectly symmetrical, and then F shows it smeared and pulled to the right. That is an example of this is perfect calibration of on and off warp drives. Here's other examples. The upper domes were tilting. Why were they tilting? There's cones that were tilting. They were tilting because the system, or the way that this works, is the warp drive is tilted to counteract Earth's gravity. It's offset at this upper element. The higher up you go away from the center of the vehicle, the more it's tilted to one side, which means the more the dome winds up being tilted. That's why it has this nice angled 20 degrees of a tilt. Same with the Hopi China from 1941 or the Trent from 1950. And then there's this bend in here. This bend is occurring because of the spatial difference from the tilt. And then flight controls. What we discovered was that if you have three nacelles underneath and one central nacelle, they add together. And if you turn one down and turn one up, you can then tilt the warp bubble and create a flight control system to activate the way it works. And in the age of disclosure, that's exactly how Howell Puthoff and Eric Davison described how a UAP flies through the atmosphere. It's a tilted warp bubble. And just some examples of lensing. I'm going to skip through here real quick. Here's one trace path we did of the light paths being bent. Here's some examples of the background being bent. These are forensic reconstructions of the dome itself. The dome has moved over time, over a period of 6 or 7 seconds. It's towards the back near the beginning, then it shifts to the right slightly, and then it shifts forward. The dome is not physically moving on the object. The dome is appearing to move because the tilt of the UAP is changing, and changing the way that the far side reflective light is being lensed through the warp bubble. And here's basically how it works. Up here, this is what we call a break. In CAD, if we were to do this at true scale, you wouldn't be able to see it. Everything would be too small. So we blow the two sides up and put a break in to indicate what's going on here is the light is bending down from the far edge, making the dome appear closer to the edge. What it is the big part of the disk is actually shrinking and the dome is staying put. Another view, it's the same sort of thing. The far edge of the disk is being pulled towards the dome, making the dome appear off center, but it's the larger disk that's being deformed into an elliptical visual shape. And then from the other angle looking at it, it's tilted to the right, and you can see here how the disk, which is the dome, is smaller, being bent and stretched out as it's being viewed from this angle because it's tilted to the right. And again, Occam's razor comes down to how did they know to do this exact spatial gravitational lensing using the elastic shape that we discovered. And so, questions?
And we went right to the top of the hour. Where's Tim? Here he is. You're muted.
Oh, sorry about that. No, and I am so thankful and excited that you guys were able to present this. So before anything else, let me bring everybody that we have in our studio. I will even bring, let me see, there's Mark. Okay, guys, please put your hands together and give an enormous applause to Chad Wanless. Chad, thank you so much. And also Dave. Dave, thank you for being here. And let me see. So Mr. Brandenburg is up next. John, would you want to do a few minutes of Q&A with Chad? Would that be okay? Or
I think
or are you on schedule? Are you
yes, it's just yeah. Let him do a few minutes of Q&A.
Okay.
While I get
let's
further
do that.
organized.
Yeah, I know. I'm sorry. I didn't mean to spring it on you. Today is somewhat organized.
I'm sorry. No, that's all right.
We have a lot of data to show, but the whole bottom line is we've written a couple papers in the book, and literally we just want to show that as engineers we have a different viewpoint and we have to adhere to a different set of rules. And as a scientist also, I won't talk about what I do, there's no rules. And as Chad has clearly showed or stated, if you make a mistake, well, you rewrite your theory or rewrite something, or you do a retraction in a peer-reviewed journal. In engineering, you can't do that. Chad has made it very apparent that if you make a serious mistake, you could have serious consequences. So since we're both engineers, and I'm also a bit of a scientist, and I will tell you, I took nuclear engineering. So yeah, I don't practice that anymore. I'm an electronic engineer, a professor in a college, part-time. Actually, I think I just retired this year. I haven't decided. So anyways, Chad put this presentation together. He just whips these things off. I love it. Chad, you did a great job. Thank you. But we have so much data. I want to just point out we're going to be putting out another paper basically on the engineering aspects of UAP detection and data. And if we can take any questions, the last thing I can say is we're starting a new website very soon. CISA.org is going to be up hopefully in a year. And it's going to be a common collective for the last 10 years of traveling to over 22 countries now and shooting UAPs, getting video, getting evidence. And we're going to be putting all that up. And then we're also going to be a database for anybody else who wants to put up theirs for people we call citizen scientists. And we want to make everybody start looking at the data and collecting it in the same manner from an engineering and scientific point of view. So we're going to be putting up some publications on how you should be collecting this data. Go ahead, anybody. Jared's got his hand up. For Chad, I hope.
Yeah, outstanding presentation. One angle that I'd be really interested in learning more about is it seems like we already have some evidence that there is some kind of plasma sheath around these craft based upon the interference with wide band RF systems like radio and TV and whatnot. When you combine that with the luminosity observations we see, that's kind of what suggests there's this plasma sheath going on that's doing wide band washing out of nearby systems. So when we take that information and we combine it with the other observations of performance characteristics from this craft, right, it gives us kind of this ballpark window on the energy requirements that we're seeing from these things, right? The Nimitz Tic Tac, that thing's doing 80,000 feet in 0.8 seconds. If you do just the math for the air moving out of the way, you're in terawatts. But if we do luminosity only, we see 0.5 gigawatt, right? So we have actual bounds for some of the saucer type craft in the few low digit gigawatts range. I'm curious if any of the changes that you're seeing in this refractive index, one, could be explained by the plasmas doing some of this refraction, and two, how close it comes to some of these other known bounds if you do only Alcubierre type changes.
Guess what, Jared? You just talked about our next paper.
Yeah.
And how we're also looking at sensor data failure, radar failure. We've got so much coming out in another paper. So we are going to go beyond the Alcubierre warp capabilities. And I think I want to point out, you're talking about a whole bunch of possibilities, and everybody goes, UAP photos are always fuzzy. Well, there's reasons, and you just added a few to them with the plasma. I call it just a warp bubble for simplicity for people, that you're going to have everything distorted. And Chad keeps putting it out. Those scatter plot diagrams, they just explain it all. So, yeah, your next paper coming out.
Yeah.
And one other last thing to add to that, for one fairly high quality video, the 2009 Paris Flying Triangle one, it's all in night vision, but that one you can frame by frame, and it's really interesting because you can watch the vapor cloud over the top surface of that thing expand and contract as it goes through a couple ignition cycles.
Can you send me the link to that?
I'll drop the link in the chat here.
Yeah,
Perfect.
please share. We haven't looked at that one. No.
Yeah, we've been trying to identify. There's not many of those leading edge vapor cones, but if it shows one, absolutely, I want to see it. John, you have a question?
Did someone? Let's see. Here's my mic. Can you guys hear me?
Yeah, perfect. Now you're muted.
Oh, yeah, you were there. Now you disappeared.
John, you're muted again. John, you're muted again.
There you go.
Okay, oh no, he's gone mute again.
You've got a delay, John, between.
I double clicked. My first question is, did somebody mention plasmas?
Yes.
Because I'm a plasma physicist, and I can attest that, yes, they can do very funny things to electromagnetic waves of all wavelengths. And but I also wanted to commend you guys for your work. And I'm a physicist, and I consider myself a pretty good experimentalist, even though I do a lot of theory. You have to be that when you're a physicist, when you're a plasma physicist. But I just wanted to say that I could never get anything done without engineers. Okay.
Thank you.
So you guys should be very proud of yourself as engineers, because if I don't have an engineer standing next to me when I'm doing something, I think I have a really bad feeling about this.
Hey, Tim.
So anyway, I want to commend you for your work.
Thank you. John, you're on next. So, Tim, instead of us keeping asking a lot of questions, can you give everybody's emails? Our next paper, I see a lot of intelligence. I'm going to put it simply in this room, that I'd like to include every one of them who might want to contribute to the next paper, which we are going to have peer reviewed and published.
Yeah, absolutely.
Yeah, we'll make it a joint effort. I mean, I see physicists, sure. I see scientists, I see engineers. Like, this would be an incredible paper. Our papers are typically about 100 pages long.
You're more than welcome to put your email up on the screen, but I don't want to write it in chat.
No.
Well, I mean, what about the?
I can do the private.
What about StreamYard? Yeah, the private.
Yeah, send it through there, Tim.
Anyway, I just wanted to mention, guys, thank you so much for bringing real academic rigor. I know academics has been neutered for like 50 years or something, but thanks for bringing real academic rigor, like Nikola Tesla or Einstein style or Oppenheimer style, to this.
All three of my heroes.
There you go.
You know, Michael, I'm on the academic side too as a professor, so I have to be very careful because academia has been hiding things for years and fighting people who are in the know. So, I have to be careful, but I think, like I said, I think I just retired this year. So now the truth is going to come out a bit more. So cool. It's been a pleasure. I don't want to hold John any longer. Chad, are you okay? We just move on. Let's email everybody, Tim. Get the emails.
Yeah, absolutely. Well, guys, thank you so much. Thank you again. Guys, everybody put your hands together and get another wonderful applause.
Thanks, Chad, for that great presentation.
Thank you. Guys,
thanks, Chad.
Thank you so much. Okay, so let me take everybody out of the room, and I'm really excited. This is amazing. John, welcome, sir, and thank you for joining us. So you sent me a paper on a test of GEM theory. Let me put that up. This is the final version of your slideshow. And since I uploaded this, you just tell me, I'll be here in the background. Just give me a back or forward when you want me to change slides, okay?
Okay.
Okay.
Let's see. I just tried to upload a slightly updated version with some more. Can I try and see if I can get that to come up?
Sure. Yeah, go for it. It may still be processing if it's a.
Yeah, it's just a PDF. It should.
Yeah,
let's see.
it might take a second.
Allow StreamYard to see your screen, and I say allow. Select window or screen.
There should be. Well, yeah, you could do that.
Okay, I'll just say. Should I say entire screen or partial screen? Let's just give it a try.
Well, you're trying to do a screen share. Do you want to upload a PDF instead?
Yeah,
Okay, so
I
click
thought
on
I'd
that
done
plus
that,
button.
but that's okay. We could just proceed with the what you have there.
Well, no, it's okay. If you just click on the plus button here, let me take this one down. I'll take that one down. So at the bottom of your screen, click the plus button.
Okay, and
then there's slides and PDFs.
Okay, and it says slides and PDFs. Okay,
and when you click on that, then it should have a few. Then it has your computer. Yeah.
Okay,
and then you just select the latest version of the slideshow that you just rendered.
Yeah, I do apologize. I thought this would all.
Oh no worries. No worries.
Okay, let's see. You seen anything? Okay, so it says present.
Okay. It may ask you to complete it. It may ask you to complete the upload. It'll take a sec to convert it too.
Oh, okay. It'll.
Yeah.
Oh dear. Huh. Okay, let's just go with what you got. It'll be fine.
Okay. I will put, just let me know previous or next, and I will be here in the background.
Okay, let's go. Okay, laboratory demonstration of gravity modification by E&M fields through the GEM gravity E&M unification theory. And I first presented the gist of this at the APS Far West section meeting in Arcata, California, about October of 24. And just to give you a little background, we'd actually done these experiments years before, but we discovered that the agency, the group that was funding us to do the experiments, actually worked for the government. And I'm just laying my cards on the table. And so I found myself part of the cover-up rather than trying to end it. And so they told us they didn't want us presenting the results of our experiments. So we were team players. I'm a defense contractor, so I said, sure, okay, we'll sit on them. Then DARPA gave me some money to do research on this theory, the GEM theory, and they specified don't do any experiments, only do theory. So we said, fine. Can we have our check, please? And then we were done with that. And finally, we basically, they handed us our check and said, don't let the door hit you on the way out of the building. And then we got a message from some people downtown in Washington, D.C. saying, we want you to publish your experimental results now. And that came roughly in September of 2024, where for years they had, basically for a decade, they had told us, sit on these results. We don't want them published. And so suddenly they said, publish, publish, publish. So I immediately, I presented here at APEC, and then I went to the APS meeting and presented there. So, and then as you'll see in the talk, the government confirmed our results. Next slide, please. Tim? Okay. Okay, first I'm just going to introduce myself briefly. You know, if you're a long-term computer guy, they call you a hacker. And if you're a long-term plasma physicist, they call you a exalted electrical engineer. And so anyway, I'm an exalted electrical engineer, and I've been working on plasmas for controlled fusion and space propulsion for 50 years. So anyway, so I'll introduce myself more completely, and then I'll talk about the GEM, gravity, electromagnetism, unified field theory. I'll talk about it briefly. I'll talk about the result that gives a vacuum Bernoulli equation analogous to the Bernoulli equation that allows us flight in air. And then we'll talk about demonstration experiments that can demonstrate this in the lab with sensitive things. Imagine you can't build an airplane, but you can take wing shapes from birds and put them in a little wind tunnel run by a hairdryer or something, and you can measure the tiny forces of lifting. And then you know that if you could just speed up the airflow, you could actually produce enough lift to lift an airplane. So basically, it's proof of principle that you can use electromagnetism to change local gravity. So we did demonstration experiments. I'll be discussing that so you guys can reproduce them yourself if you choose, and then I'll summarize. Next slide, please. This is a chance favors the prepared mind, and that's Louis Pasteur, great scientist. And he something similar happened to me in this research effort that I want to share, and I will talk about that. So next slide, please. Okay, my career since 1981, where I got my PhD. I got my PhD studying plasmas for controlled fusion at Lawrence Livermore National Lab, also known as Teller Tech. And I spent 6.5 years there, and I worked on fusion energy. You can see that ring of plasma inside. The whole thing is inside a vacuum chamber, and then you can see a jet of plasma. That's plasma propulsion. I actually invented a microwave electrothermal thruster that uses an electrodeless vortex discharge, microwave discharge to heat gases. In this case, the best gas is water vapor, and shoots it out a nozzle, and they actually have flown that in space, and it worked successfully. It raised the orbit of a satellite. Then here's a depiction of the GEM theory I'll be discussing, And then I also made an interesting detour to Mars because I basically became a space physicist because of my interest in space propulsion and the principal target being Mars. Since we'd already been to the moon 6 times, let's go someplace new. But next slide, please. So I've been working for 50 years in plasma physics, both as I trained as basically a theorist, but I did a lot of experimental work, and I became, quite frankly, I became quite good at it. And I also found that they weren't funding plasma theory much. You had to have some experiments, so I became an experimentalist and theoretical person part-time. But as I said, we had found an effect in the lab that looked like gravity modification, only we found out the research was paid for by one of these interesting government agencies in Washington, D.C., using a shell company. And since they had paid for the research, I felt that, I should respect their wishes. So they said, we want you to sit on these results, don't publish them. So we didn't. But then later, about 2 years ago, they suddenly said, publish, publish, publish. So we did, beginning in here at the APEC was the first place we presented, showing Tim's APEC forum is an excellent forum to present new leading edge research results. But I also went to an APS meeting, presented at APS, and was well received. I've become a pretty good experimentalist. And then, to my amazement, about 4 months after my presentation at the APS meeting, the White House announced that we had technologies that permit us to manipulate time and space. So this is all part of the UFO disclosure process, by the way. Anti-gravity has been basically under government control, but now they're acknowledging that they have it working in the lab. And we demonstrated that you could, using for a few $100s, you could do it in your own lab. So the government, it was the Office of Technology, it's OSTP, Office of Technology and Science and Technology Policy, made this announcement in a speech in Austin, Texas. So everything's happening in Texas. Next. Now, why are we interested in gravity modification from unified field theory? Why would we think that this was possible? Well, Albert Einstein, E equals mc squared, invented the black hole, the gravity wave, all these things. He's a really smart guy. He spent the last 30 years of his life trying to unify the two long-range forces of nature, electromagnetic force and gravity force. Of course, there's 4 basic forces in nature. There's the strong force that holds the nucleus together, the weak force that basically holds the neutron together, and then there's the electromagnetic force, and those are short range. They only have force fields that extend roughly the size of an atomic nucleus. But the electromagnetic force and the gravity force reach all the way across the universe. So, and they both follow the inverse square law. So Einstein believed fervently that they could be unified in a new theory. So he tried this and that, but one thing that he missed was he didn't like quantum mechanics. he said, God doesn't play dice with the universe. He said this in a debate with Niels Bohr, who invented the quantum mechanics of the hydrogen atom. And Bohr finally roared back, quit telling God what to do. In my own private imaginary conversations with Al Einstein, I said, Al, God may not play dice, but he does own a casino where dice is played. So you must admit that quantum mechanics works. It gives you answers. Things like the laser, things like quantum computing. These things function, and they function using the laws of quantum mechanics. So you can't ignore that, even though Einstein wanted to ignore it. So we're unifying, but we're following the idea that we're going to unify the two long-range forces of nature and consider the short-range forces to be not that, just details. Next. Nikola Tesla, one of the contemporaries of Einstein, they didn't get along. But Nikola Tesla also reported such a unified field theory was possible. He was more of a experimentalist, and he claimed he was getting experimental results reporting anti-gravity. And remember that. Of course, then he died in the middle of World War II after the Philadelphia experiments. And the uncle of our president, a certain guy named Trump, showed up with the FBI and cleared out everything in Nikola Tesla's apartment, including rolls of toilet paper where he would scribble equations. And so they classified all of Nikola Tesla's work, and you can't blame them. They were fighting World War II at the time. But anyway, so Nick Tesla believed it was also possible to have a theory of anti-gravity. And that's a theory that unifies, you can change gravity into electromagnetism and electromagnetism back into gravity. So, next. Now, two fellows named Kaluza and Klein made an interesting discovery. It was really purely mathematical. But they found that they could get the mathematics of Einstein's general theory of relativity plus Maxwell's equations, the equations of electromagnetism, and the E equals mc squared form, the energy density of the electromagnetic field would be a source term for the gravity fields of curvature space. All of that math could be worked out beautifully and perfectly by adding a new hidden fifth dimension. So this is called Kaluza-Klein theory. And by the way, the unfortunate thing is this led to string theory, which has preoccupied, has been the bright, shiny object of physics, theoretical physics, for 30 years now. They've spent billions of dollars. And apparently what they've done, the government did, because it controls funding on who gets theoretical money to do theoretical physics, they've basically been gaslighting the entire community so that they won't find the equations of anti-gravity. The equations of anti-gravity are considered classified. So what they do is they have people trying to do string theory that unifies the strong, the weak, the forces, and E&M, and occasionally gravity, all in one theory. And it's been like a quest for the Holy Grail, and it's produced nothing. So on we go. let's be more humble. Rather than trying to make a theory for everything, let's make a theory for what we see in front of us. Next. What happened was Clouseau and Klein found that, Clouseau found the equations that unified gravity and electromagnetism perfectly, but it used this fifth dimension, and then Klein explained that the reason we couldn't see the fifth dimension was because it was hidden. And he demonstrated all the math for that. Now, let's assume that this hidden dimension has actually a size, and the size, it turns out, is roughly the size of a classical electron or proton. And it's logarithmically, well, basically, when this new dimension forms at the Big Bang, you have one field, you have one force field, and one type of particle, plus and minus versions of the same particle at the Planck mass. And then the hidden dimension explodes from being the size of the Planck length, where everything's the size of the Planck length. It explodes to the size of a subatomic particle, a classical particle radius. And this, imagine that both of these things are correlated together. So the separation of, you start out with plus and minus versions of the same particle, same mass, and that's related, the masses, the ratio of their masses, or the square root of the ratio of their masses, is related to logarithmically to the size of the hidden fifth dimension, which is deploying, relative to what's called the Planck length. And I'll next phase. Now, this means you have incorporated quantum mechanics, which Einstein hated. So he rejected quantum mechanics. But it's quantum mechanics that's key to unifying E&M and gravity. And the best way to illustrate that is gravity and the quantum zero point forces, or quantum zero point around us, was investigated by Stephen Hawking. And according to Stephen Hawking, you could start with a black hole, pure gravity. There is nothing material there. The space-time has tied a knot in itself and it can't untie it. Then, because of the quantum zero point fluctuations, the black hole, which is pure gravity, makes a transformation. It starts leaking. It leaks gamma rays. And finally, the whole thing blows up like a firecracker. So you start out with pure gravity in a black hole. You end up with a cloud of gamma rays, which is pure electromagnetism. So Stephen Hawking showed basically that gravity fields can be distilled into pure electromagnetism. That's the conceptual breakthrough. So next phase, next page. Now, of course, gravity as we experience it doesn't have anything popping like firecrackers. It's just like if you have two objects out in space, mass 1 and mass 2, the force between them is given as the mass of one times the mass of the other. Mass of one times mass 2, and then the whole thing divided by the square of the distance between them. So it's an inverse square law, like just like electrostatics. But you have to have this magic constant, the constant that runs the universe, big G, the Newton gravitation constant. Next. So that's central. Now, the Planck scale takes that, if you take quantum mechanics and condense it down to very tiny sizes, it becomes a quantum event. You can have a Planck length, a certain size for these little black holes that form. The Heisenberg uncertainty principle allows you to have things, particles that appear and then disappear. And that's analogous to these quantum black holes forming and then doing Hawking decay into back into electromagnetism constantly in the space around us. And the size of these little black holes is the Planck length. Their mass is the Planck mass, which is roughly the same weight, same mass as a speck of dust. And then you have also what's called, could be called the Planck charge, which is the Planck's constant times c. The square root of that is actually gives units of electric charge in what's called CGS units. So you don't have to worry about physicists. Theoretical physicists love CGS units because it means you don't have to carry the mu naught and the E naught, epsilon naught around every place. So next one, Tim. Okay, the basic theory that we're dancing around then becomes this. There's an effect in plasma physics called an E cross B drift, or pointing vector. Pointing vector gives the radiation pressure of light. And it points, was invented by a guy named Poynting. It's an old English name. And it points just by, it shows that God is a punster, by the way, because it actually points in the direction of the radiation pressure of like a laser beam. Will press on things and the force vector is given by the pointing vector. Now, that means we're surrounded constantly by 0 point fluctuations of the vacuum because of the quantum uncertainty principle. And this means we are surrounded by a sea of pointing vectors randomly pointing in various directions so that they all average to 0. Okay, out of that apparently comes the radiation pressure that causes all the charged particles in the universe to want to cling together, a gravity force. I'll show you how that occurs in a minute. The gravity, okay, so now gravity and electromagnetism exist as separate fields along with protons and electrons due to the existence and deployment of a hidden Clouseau-Klein fifth dimension. So you start out with a 4-dimensional vacuum that's empty, and it's got one force and one type of particle, and then boom, suddenly this fifth dimension appears, and it causes a separation between gravity and electromagnetism. So they become separate and distinct forces, and the charged particles that were there in the vacuum as quantum fluctuation particles suddenly turn into particles that are stable, and one is the proton, a positive charge, and the other is the electron, a negative charge. So that's the basic gem theory, is that Gravity fields are equivalent to a certain configuration of electromagnetic fields, and I'll show you what that is in a minute. And the second assumption, postulate, is that gravity and E&M exist as separate fields along with protons and electrons due to the existence and deployment of a hidden Clouseau dimension. So it pops out of the Planck scale and explodes like a little exploding universe. And when it's done, we'll show you what happens. Next phase. Next page. The basic gem theory says that before the Big Bang, or at the moment of the Big Bang, you had nothingness. You just had bare vacuum, but it was a quantum mechanical vacuum full of zero-point energy. Then the Big Bang happened because the triggering event for that Big Bang thing was the appearance of a hidden fifth dimension. I mean, just imagine a hand without a thumb. And then suddenly the thumb appears, and the thumb makes everything possible, just like it does for human beings. So at time equals 0, there's nothingness. Then the Big Bang happens with this deployment of this hidden fifth dimension from being the size of a Planck scale along with everything else to suddenly being the size of a subatomic particle. And suddenly now you have, instead of one force, you have two forces, E&M and gravity, and you have two particles, two charged particles, one proton and the other the electron, and that forms a hydrogen plasma. So that's 1 second afterwards, and this is standard Big Bang theory. Says this, you start out with nothing, and then 1 second later, the universe consists of an expanding fireball, expanding plasma of ionized hydrogen, protons and electrons. Next. Now, you say, how does the pointing vector give you a model for gravity? Well, let's say you're up in the space station, so you're in a weightless condition. You have a box, a metal box, let's say it's made of titanium or tungsten. You put two white hot ball bearings floating inside, and the two white hot ball bearings, because of mutual radiation pressure from the bright light from each of them pushes them apart with an inverse square law repulsion, just like electrostatics. Now, do the opposite experiment. Instead of having two bright objects in a dark box, take liquid nitrogen and chill the two ball bearings, let them float in there. They're dark. They're not emitting any infrared or other visible light. And you heat the box with like electricity, so it's white hot. What happens? The two ball bearings start attracting each other because they get radiation pressure from every direction except on a line between them where they mutually shadow each other. So you get what looks like gravity between the two ball bearings, and it follows the inverse square law. So next, so that's how you get the pointing vector gives you a model for gravity fields. There are no gravity fields there between, or anything to speak of between the two ball bearings. It's all done with electromagnetism, but it looks just like gravity. Now, if you have a formula that says the expansion of the fifth dimension from the Planck scale, which is given as a logarithm, that correlates or equals the change in the square root of the two masses. The square root, by the way, of the ratio of the mass of the electron to the proton is the number 42.85. So just like Hitchhiker's Guide, the key to this theory is the number 42. Strange but true. Now, you can invert that formula and get an expression for big G, the Newton gravitation constant. This is the formula you get. It says it's determined by the electric charge squared of the mass of the proton over the mass of the proton times the mass of the electron. So it's a charge to mass ratio squared is big G, times alpha, which is the fine structure constant in quantum mechanics, the number 137, and then this exponential term. And that gives you the Newton gravitation constant to within a part per 10,000. You can see it's a very simple formula and gives you a very good result. Also, you get the mass of the proton from this model, and that gives you to within about 4 parts per thousand of the measured value, 0.4% of the actual measured value of the proton mass. It actually gives you both the electron and the proton mass, but the proton is where the mass is the mass determiner of the universe. So, so you get these two fundamental constants of nature from this theory and nobody else. I'm sorry. I've been given Texas bragging rights. Nobody else can get these results. What does academia say to me? This is numerology. Where are your strings? Where's your string theory? What about the weak force and the strong force? It's just an approximate theory. I'm not trying to make a theory of everything. The theory of everything is TOE, my big toe. All right, I'm not interested in my big toe. I'm interested in the whole body. And the whole body runs on the long-range forces of nature, gravity and E&M, including anti-gravity spaceships. So next, how do we use this theory? Okay, if you look at and I'm not going to bore you with the mathematical details, you can find that the function that gives you a minimum in this theory is what I call a vacuum Bernoulli term, where in the Bernoulli equation, you have pressure, static pressure, and then you have dynamic pressure, and the sum of the two is equal. Here, it's the difference of the two. The electromagnetic pressure and the gravitational energy density are differenced. So, you can integrate out a vacuum Bernoulli equation based on the Poynting vector and the strength of the gravity fields. Next. What does this mean? It means you can locally imagine you have gravitational lines of force, just like electric and magnetic lines of force, and you can get them to bend around an object with electromagnetic fields. And as a result, the gravity on the coil where the electromagnetic field is slightly less than it is if you turned off the power. Next. Now, we first noticed this because it was reported by two fellows, Hayasaka and Takeuchi, that they spun gyroscopes with Tesla three-phase power. When they spun them in one direction, they lost weight. When they spun them in the opposite direction, nothing happened. We got funded to repeat that experiment. We found, and this is where chance played a role. One fellow I worked with had read that the Russians had reported the same result in 1968, a guy named Kozyrev. I tracked it down. I found out, yes, the Russians had reported the same effect. And then they couldn't understand it, so they just published it. So we reproduced the experiment as exactly as we could. And guess what? We got the same results. Next. Then we found out something amazing. One of the bearings on one of the gyroscopes we were using were old and they quit working. So we took out the rotor. And just to see what would happen, we ran the coils without the rotor. It lost even more weight. The gravity got even weaker without the rotor. So we found out that just about any coil, if you activate it with AC, you will get a weakening of local gravity. We finally were hanging little toy motor armatures with laminated iron underneath of helium balloons, and we got them to lose weight when we turned on the power. When we turned off the power, they returned to their original spot. Next. To do this, you need to make a phone booth. Some of you don't even know what a phone booth is. It's just a kind of a rectangular prism made of PVC pipe, and you wrap plastic around it. It's to keep the air still when you do this experiment. So you can float a little helium balloon inside with the coil run by wires, and we have discussed this on previous occasions. Next. This experiment can be done for probably $200. I hope to demonstrate this experiment at the Tesla conference in Albuquerque in August. Next. Okay, here's how, that's just a cookbook on how to do this experiment. Next. We've done this experiment several times. It works. You need above 400 hertz to get it to work for some reason, and you have to run the about 11 to 12 volts through the coil. Next. Now, we want to go to three-phase power rather than just single phase. That requires a little bit more money to be spent, but they've perfected three-phase motors for all these drones. So here's an armature, a stator, the coil for a three-phase motor using rotating Tesla fields. Next. This rotating field we call it a Tesla vortex Tesla pointing vortex. It should be TPV, a TPV. Yes, I got the numbers, the letters mixed up. But you can show that on just with a sensitive chemical scale, if you power this thing up using liquid metal contacts, Gallistan contacts to supply power, so there's no power coming down there's no force being transmitted with the outside world to the wires. You turn it on, it loses weight. You turn it off, it it returns to its normal weight. Next. Now, people complained that the three-phase power from the coil was interfering perhaps with the sensitive electronic scale. We verified that this was not the case. We would hang the coil over the scale and turn it on and off. It didn't affect the scale at all. We were running at 400 hertz that just didn't not couple to the electronics in the scale. Now, but just to make things better, we got a load cell and hung the three-phase coil, complete with the Gallistan contacts. We hung it by just a nylon thread beneath the load cell so that the fields from the coil could not affect the load cell. And the weight could be measured without any chance of electromagnetic interference. Next phase. So, and these are some of the results. I'm going to give you the reference so you can do this experiment yourself if you want to. Next. There's the coil stator. Next. There's a controller unit. You can get all of this stuff ordered through Amazon. Next. There's the load cell. And next, there's the electronics that reads out the load cell signal conditioner. Next. Now, here's the experiment we did. We found that the controller on the three-phase circuit, since it was meant to run toy motors, would not instantly change frequency, or which meant changing the frequency, the rotation frequency, so that we had to give it a second to adjust or so to speed up, because it was intended to run mechanical stuff, so it didn't want to break axles or gears by instant torque shocking. So, but we saw without any trouble at all 150 milligrams weight loss, so that's 0.15 grams. And next, and then we, just to be careful, we ran the, we supported the coil and then turned it on and off to see if it was affecting the load cell. And all we got was random noise of, 4 milligram type of noise. So it was successful in that it wasn't talking to the load cell, and it was giving a very clear signal. We got very good signal to noise ratio on this experiment. So next. So it is possible to make anti-gravity using the vacuum Bernoulli equation from the gem theory. Now, you could make a flying saucer based on the regular Bernoulli effect, because of the, but the vacuum Bernoulli effect has a negative sign, where the regular Bernoulli effect has a positive sign between the static pressure and the dynamic pressure. So the design is slightly different, but you can make flying saucers using this theory if you have enough power. Next. So in summary, the gravity modification directly by E&M fields can be predicted from gem theory. 3 experiments can be performed easily to demonstrate small scale gravity modification. Don't pack your bags for Mars yet. There's a lot of, dare I say it, engineering must be done to get this thing to work and to fly human beings anyplace. But this effect can be seen in the lab in small scale, and it works. And the White House has confirmed that the US government has this technology. So gravity modification directly by E&M fields is now a demonstrated reality. And that's the talk. And it's 3 o'clock. The mouse has run up the clock.
John, awesome. And you have a couple of slides left. Let me see.
Yeah, let me. These are basically just let's run through them really quick.
Oh, backup slides. Okay, backup slides. There we go.
They're backup, and this one shows that using plasma physics, how you can create what looks like a gravity field, only it's all electromagnetic. If you have two plates and the magnetic field is coming out of the plane of the picture, the two plates are at different voltages, an electric field, so there's magnetic field crossed with that. Any charged particle you put in there, proton, electron, charged uranium atom, whatever, they will all end up moving in the same direction at the same speed. Now, if you tilt the two plates relative to each other so the electric field varies from top to bottom, then you can get them all to accelerate together, and you can actually easily simulate this using simulation codes. So you can simulate that. You can prove that works. This is just a mass model for the proton, and there's a small QED correction. As it turns out, you can improve even on the estimate for G, the theoretical formula for G, and the theoretical formula for the mass of the proton can be improved slightly, so they're even more accurate. And it involves quantum corrections. Next. This is just a Kaluza-Klein theory. Next. The value of G, and there's 42.85, just like in Hitchhiker's Guide to the Galaxy. The secret to life, the universe, and everything is the number 42. Well, it's closer to 43, but we're not going to be we're not going to be persnickety about this.
So, John, on that note, I'm going to bring everybody back in here. We need to give you a massive applause. Oops, wait. Oh, there's Dan. Okay. Guys, giant applause for Dr. John Brandenburg.
I'm deeply honored, you guys, to be
addressing.
And John,
let me apologize for not responding more to your emails. As you can see from my background, I had to leave my studio behind. I moved across town.
Oh my goodness, what happened?
Oh, time for a new place.
Oh, there's three things I hate most, and moving is two of them. I hate to move. Moving is chaos.
It was a lot of work.
Come on, Tim. Tim, time to do AI and make your studio without lifting a hammer. Come on.
Well, I will get it up and running again. I'm going to work on something that's more portable this time, and that way, next time I move, that will make it easier. So
we get to ask John questions.
Yeah,
go for it. Yeah, so those are all three of our presentations.
AI will say, who needs a roof? Who needs a studio? And so you'll replace all of that with AI, and then the AI will finally one day ask, who needs you?
Don't get me started on AI, please. This is not the subject.
Don't get me started. I know. Good.
John,
I'm glad
there's
somebody else has seen this. Yeah.
John, what year did you first do the experiments and you were told to hold the results?
I did the first experiments with the gyroscope where we discovered if you took out the rotor, we did that back in like 1998. So
Okay,
almost a quarter century ago. And
was
we
this
were
through
basically
DARPA?
told in no uncertain terms. No, we were funded by a company that said it was interested in UFOs.
Okay, so you then mentioned DARPA. Can you
And
tell
then
me?
they
I
turned
missed.
out to be a front for the CIA. What's
But
that?
you also mentioned DARPA. What was the relationship between this experiment and DARPA?
Well, what happened was I presented this at a conference, kind of low key. And I mentioned we had these experiments. I basically just presented the theory, and there was a guy from DARPA at the conference. And he said, I want you to apply for funding from us.
Okay,
I
so
said,
the
yes,
reason
sir.
the reason I'm asking you all this is because 2 years ago I was asked to sit on a committee of engineers to get anti-gravity propulsion up and running physically using the information that you just told us and a DARPA patent. That's why I'm asking.
God.
And by the way,
well,
it hasn't gone anywhere because our chief engineer passed away, who had half.
Oh, too bad.
Half the patents for the motors that we needed, but secondly, I need to let everybody know I'm Canadian. I had nothing to do with the U.S., but I was asked to be like second in this committee that is still standing and not doing anywhere. They want to build it.
Dave,
just tell you, they want to build it.
It turns out the company that funded us was from Canada.
You don't have to tell me. I already know. But I can't disclose anymore.
Well, obviously, they're trying to spur economic development in the great.
Yeah, they want.
You got told.
They want private funding to put up $6 billion to get this off the ground. Literally off the ground.
Off the ground. More power to you, Canucks.
You could
Show
do
us
that
how
at
it does.
100th the price.
Sorry?
Give me a 100.
Well,
give me a 1,000 to that, and I'll get
trim
off
on
the
it.
ground.
Well, our budget came up to a fraction of that, but it's a government, U.S. government. Say, okay, that'd be $6 billion. I said, what are you talking about? We're talking about 20, 30 million. That was it.
I can still do it for a tenth of that.
The rest goes to trade shows.
The boys downtown, they're worried.
Politicians and.
So I found your presentation fascinating because I've already been through all this, and it's. I don't know. Maybe
you saw this before.
Yeah.
Let me get this. Let me understand you perfectly. You saw this presentation sort of stuff 2 years ago.
Yeah, probably was your presentation.
Okay, that was what I made to. I presented the experimental results to DARPA. Not the latest fancier ones, but the earlier ones. And let me tell you, I'm a team player. One thing that makes Americans a little bit different than Canadians, we're a little bit more regimented than Canadians, and we tend to go with whatever the quarterback says to do. And what they did was they wanted to know what I knew.
All right. I'm sure other people
They
have
wanted
questions.
a full briefing.
Yeah, let's other people ask questions. I've already been through this, and I'm surprised what's going on because I don't know if our committee is dead in the water. We haven't had a meeting for almost over a year now because of the passing away of the chief engineer. So,
John?
I'll shut up.
I got to tell you guys, it's been my experience that nobody cares about this topic. I mean, we've been to the Air Force, Space Force, Army, Navy, Marines. We've been to DARPA. Nobody cares. Literally nobody cares. They're very happy with their chemical rockets and their little ion thrusters and nobody cares about this nonsense.
Yeah, you wouldn't need oil. We already know what's going on.
That's right.
That's why I
John,
think we're not going anywhere.
So, John, it's been a while.
Yes.
Yeah, so I you know about Jim's passing in August, and I know that you were involved with the NIAC. So I sent you an email. Let's get in contact sometime. I'd like to talk to you offline about what's happening next with Jim's work.
Sure, Curtis. We can arrange that through Tim. Tim will be able to facilitate that real well.
Okay. I have a lot to say, but
just,
it's better to
you
say it
can do
off.
that,
So maybe I've got a question, John. What is your plan to continue this experimental program? Are you trying to do the experiment in different ways and solidate the work? And also, are there other groups which can replicate the results?
Joel, this is a very good question. Now, I'm an experienced experimentalist. I'm very proud of my experimental work, and I always try to be my best critic. And I always try to make my devices look really good and polished. Some people don't feel that way, and so I've had people who say they're interested in reproducing my experiments and produce junk. I mean, you know, I thought my 12-year-old nephew could do a better job at experimenting. One guy was anyway, let's just say you have to be pretty good at doing experiments. Like David, as an engineer, he knows what I'm saying. You know what bad engineering looks like, and you know what good engineering looks like. And I ended up giving all this data to some people who were very bad experimentalists. And I finally just gave up trying to help them. I mean, and they quit talking to me. And
so maybe now, after you've done this presentation, some labs will maybe pick it up. And also,
yeah. Let me go to Jared. Let me pick on Jared real quick. Jared has his hand up and put it down in dismay. Jared, what do you got?
Yeah. Joel, we'll return to you in just a minute.
John,
Okay,
outstanding presentation as usual. My question is, I always start off any experiment by going to existing experiments, right? So if there's satellites up there that have flywheels, and they've been doing that for 70 plus years, whatever, I would have to imagine that some of those flywheels, not all, but some of those flywheel setups might be close enough to your GEM experiment that there might be useful data within those where you could see in the short windows of time where they have an asymmetry in the flywheels. During that time, you could see, is there a deviation from prediction that matches your prediction?
Jared, they did an experiment where they had a very, very highly instrumented kind of flywheel kind of experiment up there. And guess what? They got results they did not expect. And so they said, obviously, there's something wrong with this experiment. And that's the last we've heard of it. Unfortunately, the funding agency for satellites ultimately is the U.S. government.
I would love to see you include that experiment in your presentation.
Well, they basically took the data and said, well, this data is obviously wrong. We need to adjust it. So they put in a diddle factor. That was after I read the article, I thought, gee, these guys put in a diddle factor to make their experiment agree with what they thought was the theory. and then you didn't hear anything more about it. And
hey, John.
so, you know, they put a diaper on it.
I saw
Yes, hey,
Martin
Michael,
Taj-
how you doing?
Good, good. How are you? I gotta talk to you soon about
you saw
a number
Martin
of
Tajbar.
things. Yeah. He tried to replicate that, and it's crazy. So there's the group in Australia who did the experiment, and they got the opposite result. It spins in the opposite direction when you're in the southern hemisphere, and then Martin Tajbar just averaged those two together and got zero.
Excellent.
It's so dumb. Like, why wouldn't you?
Oh,
I mean,
that's pathetic.
Wait, Michael, you're saying that Martin averaged the two separate experiments, one
so
in the
he
northern hemisphere and one in the southern. And
yeah,
said
he
that
did a review article. He did a review article, and he said, "Oh, the Japanese team got this. We tried it ourselves. We got this. We're in the northern hemisphere. In the southern hemisphere, they got the opposite spin result, and then they just averaged those two together to get zero. It's ridiculous. And they didn't even have the same number of tests." It's
crazy. It's
Martin,
really interesting. When I was asking
my
Jim
congratulations. Tell Martin I am in awe of his experimental acumen. I'm being sarcastic, of course.
I was asking Jim about including some of his work as reference, and the answer was this. So, yeah, I'm not surprised.
So, John, I had one quick question for you as well.
Woodward.
Have you?
Jim, yeah.
Yeah, Jim Woodward's good. So, John, I had one question. You have this Bernoulli equation. Have you?
Well,
have you tried a Bernoulli equation? Oh, sorry. Maybe there's a delay. Do you have the Bernoulli equation? Oh, yeah. There's quite a delay now. So that's like a second or so.
Michael just asked a question.
Yes. So, have you tried a Bernoulli equation with compressibility for your model? Because that allows for some interesting possibilities.
No.
Well, I recommend it.
This is just the beginning of a theory. This is just the beginning. We've landed on a new planet here, and and also we know there's a big classified program doing this with billion-dollar budgets, trillion-dollar budgets.
Yeah, we're playing catch up here.
How are we supposed to? We're playing catch up.
And
we get a tiny effect that shows.
Now I can ask. Now I can ask
Drew,
where your Reynolds number is.
Good point. Good point.
They spent $60 billion on SLS. How's that looking?
Yeah, right. Maybe that funding didn't all go to SLS.
It did. I watched them waste it.
That's nasty.
I'll tell you. Yeah, the answer, Curtis, is what is the Reynolds number? It's the number 42. There.
There you go.
That's funny.
And as far as the SLS, I went to a dinner in Huntsville, and Hal Puthoff gave a wonderful address. Hal Puthoff's theory of gravity, E&M unification, is very similar to mine. And we communicate, we pass our stuff back and forth. But in fact, I can get the Bernoulli equation, vacuum Bernoulli equation, from his theory. And I wrote that up and published it and sent him an article, and he was very pleased, that I but on the SLS, I was in Huntsville at this meeting on theory of advanced propulsion, and I was sitting at a banquet table. They had a banquet, and the guy next to me was from Boeing, and his badge said SLS development team. And I said, they handed you guys a bunch of Tinker toys and told you to assemble, take the shuttle solids and the shuttle tank and the shuttle engines, all of it flight proven, and assemble a new Saturn V class rocket out of it. And how long has it been? It's been 20 years. You guys are over schedule and over budget, by just incredible amounts. And he laughed at me. He says, "You don't understand. That's our business model."
It's a work program. Yeah.
He says we always
keeps them
smart people.
Keeps them busy if they're not read in. Sorry.
Yeah.
I spent 12 years on that program.
Well, guys,
nothing you can ever learn will tell you how bad it is.
Do you guys want to go to lab updates now? Should we do lab updates?
That was 5 years, Yeah, we're getting off the subject, but I told him, I said, Elon Musk is going to eat your lunch. And sure enough, so I had that conversation with him, that Boeing guy 7 years ago. And guess what has happened? Musk has eaten their lunch.
Yeah, they're not even allowed to
Yes.
send stuff to the space station anymore.
Nope. Complete failure. Curtis.
Yeah, I do have a question about your theory. I noticed that it's based on the Clouseau Klein. What I always wondered is what's the good physical reason for adding a fifth dimension? I mean, for 4 dimensions, there's a good reason because we have like an extra degree of freedom time. But other than hey, I can write a formula that includes E and M. Is there another physical basis for that you know of?
The only one I know of is that you can't hitchhike without a thumb. In the Hitchhiker's Guide to the Galaxy, the number 42, the fifth dimension acts just like the 4 fingers are space-time, X, Y, Z, and time, and then the thumb, shorter than the others, is what makes everything possible. And it's a mystery why we got 5 fingers. I don't know, Curtis. It's when Einstein first saw the Clouseau Klein theory, it was sent to him because the journal had rejected it, and Clouseau sent it to him, to Einstein, and Einstein just said, this is foolishness. This is bull. This is nonsense. What does the fifth dimension do? And he says, it's just a placeholder. It's a zero someplace. It's a place to put a zero. And he rejected it, but then later he came back and looked at the math. And for some reason, it makes all the mathematics of Maxwell's equations and general relativity fit together. So, Curtis,
yeah,
if I was smarter, I would be able to answer your question, but I'm not smart enough to figure out why is it the fifth. Yeah,
no, that's a good motivation on its own. I just wonder if there was another one. Yeah, go ahead, Michael.
Hey, I have something to add here. Recently, David Chester and I have been looking at Brand's-Dickey theory as a potential alternative to Clouseau Klein, and it can do all the same stuff with the usual 4 dimensions plus a scalar field. And a few, but
well,
there are other. Yep. Go ahead, John.
I'll mention to you that out of the Clouseau Klein theory, a scalar field magically appears. It corresponds almost to a vector. It almost like a sound wave, an electromagnetic sound wave. It's just, and remember, Tesla swore there was a scalar electromagnetic field.
Yep,
and
exactly.
He could control it but that disappeared with all his papers.
Mm-hmm.
When the Trump's uncle came through with the FBI and took everything out of his apartment.
Well,
it was
I
the
think
middle of
I think
a war.
we've
I mean, you can't just
I think we've got that piece together more or less. I mean, you've got the Lorentz scalar component, which is typically set to 0, and that seems to connect. Well,
Yes.
it easily connects to a scalar component, and that's why I mentioned compressibility and the other thing. But I won't go any further for now.
Yeah. So guys,
So, Michael,
let's take
I
this.
will just say that Brandenburg theory could be considered to be a Clouseau-Klein-like theory because the major consequence of Clouseau-Klein is this scalar field appears. And it suggests you can use that for communication and things like that. But no one, what's interesting is you never hear anyone talk about it.
Yep, exactly. Brandenburg doesn't get
So-
any mention usually.
Well, yeah,
And
that's
it's,
one of
it's
the
a-
main things
No.
they did is bring in
Okay.
inertia, and so
So
that
guys, let's
something
take
that's,
this to let's move, if it's okay, let's move into, I want to move into lab updates now. Or
Sure.
if you guys don't have any, we can go into open discussion if that works.
Mind if I finish up one more
No,
thing
that's
I wanted
okay.
to
That's
say?
okay.
So,
Well, yeah, I would say finish this up and then let's
Yes.
move on.
all right. So it's interesting, just the historical context of Brandenburg theory. I believe Eric Weinstein actually was digging around, and he's like, "Oh, what's this UNC Chapel Hill conference that happened in the 70s?" It's just interesting that Dickey developed his Brandenburg theory after attending the Chapel Hill conference, and then 7 years later, then that's when the flux liner was reported to exist, which seems to use principles from Brandenburg theory. Anyway, that's all I'll say.
Okay. So guys, on that note, let's put our
Interesting.
hands together
I can-
one more time for Dr. John Brandenburg and really
Live
nothing's
long and
changed,
prosper.
but- Well, John, you're more than welcome to hang around. We're at the bottom of the hour, so so I wanted to try and segue things in so we don't get too
Okay.
sidetracked before labs.
yeah. So can I go
Yeah,
first?
yeah.
Since,
I'll be around for another hour.
Yeah. Curtis, do you have updates on?
yeah,
I'll be I'll be around for another half hour. Unfortunately,
Okay.
I
Okay.
can only be around for another half hour. And but anyway, guys, it's been an honor and pleasure to address you all. And by the way, I'm working on fusion energy now, and one of the major resources we have, David, is the CANDU reactors up there in Canada. That's such a clever idea, and you guys make all this helium-3 for us.
Yeah, and wait till you see the mini reactors that are coming out.
Oh! I just think it's just fabulous.
Imagine
it's a very Canadian approach to things.
Imagine making a giant data center, which we know is coming on with a request because of more AI. I know, don't get me started. And there's a little building right beside that building, and it's a mini nuclear reactor. Right on the same property.
Well, David.
Okay. Well, let's go to.
There are
let's
more
go to
uses for compact reactors and fusion energy than powering AI.
Look, my best friend who passed away a few years ago, Stanton Freeman,
indulge in a little treachery to use.
Did you know that Stanton Freeman back in the late 60s or early 60s created a nuclear-powered space rocket? Good friend of mine. I'm so sad when he passed away.
Okay. So let's go to
Stanton
Curtis.
Freeman was just a genius.
You could put the hottest reactor in the universe on a rocket, and you ain't going to get past about 8,000, maybe 6,000 ISP. You're still wasting your time.
It was it was an experiment to see where it could go. Imagine 30 years later, it would have been awesome.
It's going to go to about 6,000 ISP. It's going to cost you $1 trillion. And then the environmentalists are going to shut you down, and you're going to be right back where you were 30 years later.
Not my money. Yes, you are right.
But it's my money. I pay taxes.
I know.
I don't want to see them wasted anymore.
My money is creating
Get
reactors.
the Americans to pay for it.
Whatever.
No, my money's made. My taxes go to the CANDU reactors. I'll tell you right now.
So guys, let's go. Curtis, can you give us an update?
I'm having too much fun listening to these guys, Tim.
Okay, well,
so, anyway, it's okay.
I'll just let
I'll
go
proceed
for a while then.
So I'll proceed.
I'll be right back,
so John,
all this talk about effective, how much power you need to do this, that, and the other thing. I mean, I've hit unity on microwatts of power. So none of the standard energy equations that tell you, oh, you're going to use 50 trillion watts or 100 watts or whatever, none of that's worth a squat. You start getting into this electrostatic pressure, propulsion,
and that's
maybe
one
this
of the
albuquerque
reasons,
warp thing. None of it's worth a squat.
Yeah, I agree with you, Drew. Especially the stuff on the purported UAPs and the energy they use and doing analysis. I unless we really know what's in there, none of that holds water. We got to be really careful because we don't know the mechanism. Unless you know the mechanism, you don't know the mechanism.
Exactly. There could be a Lagrangian that corresponds to the system. That once you have that, you see that the energy requirements are a lot lower in some context, or the definition of energy might not be what we think it is.
Well, even what you're doing, right? There's a lot of talk about gravity manipulation, but really gravity and inertia being unified, you could just be manipulating inertia locally. So, and that's what Jim was working on. But
even so, if you take inertia and gravity, and you can change the inertial to gravitational mass ratio, doesn't that already break CPT symmetry though?
So slow down a second. Inertia and gravity are two separate things, but we find that they're not separate things, right? So the separate thing, being separate in terms of separate things, there's a inertial force regardless of gravity, but then gravity, if you use the same mass, there's something called the equivalence principle that Einstein uses, right? So what we find fundamentally is that the same thing is down deep. And so there's not separate like equivalent numbers or separate fields. It's one field. So inertia and gravity, part of the whole relational Machian line of physics is, one of the things you do is unify those. And that was what Einstein was trying to do when he ultimately developed GR. But his GR wasn't a true unification of gravity and inertia. It sort of unified it, but not in all aspects. So that's one of the things. But the other thing I wanted to say, the reason I brought up the Clouseau and that question, John and Michael, was that I think I've sent you guys, I don't know if I sent it to you, John, but I've sent you guys my work. So basically, Jim and I were working on a unification. When I say unification, really, we were working on a mechanism for inertia. And so that got finished. The first draft is out there. Hopefully you guys will get a chance.
And by Jim, you mean Jim Woodward?
Yes. Yeah.
Yes. Thanks, Curtis. I have briefly seen it. I need to spend more time reading that to really grasp it. But I do really like your idea of particles as topological solitons. That's got to be part of whatever the final theory is, I imagine.
Yeah.
I'm excited by that.
Yeah, it's great. And it took me about a year to accept it. It was a lot of cognitive dissonance going on at that time. But
is there I haven't gotten that far yet, but is there a parallel between the strong force and the Casimir effect in some sense? I just out of curiosity.
You could say that.
Nice.
Yeah, you could say that. Although, how would I put this? The strong force itself is sort of, there's two strong forces that you want to talk about, right? One is the force inside of like a proton, and the forces between protons and neutrons. So if you're talking about the interaction between protons and neutrons, then yes. But
yeah,
go ahead. Within an elementary particle, that would be something else. in the theory.
I totally agree with that because you can view the protons and neutrons in a sense as electrically conductive droplets of quark gluon plasma, and so there must be a similar analogous interaction between them. And then when you look at the exotic vacuum object research, they have these things that seem to be stable over much longer timescales than plasma physics says they should be. And what's obvious to me out of that is if you get a dense enough plasma out of a Z-pinch or similar effect, that plasma, the plasma frequency of that dense plasma might even be able to exceed the plasma frequency in metals, and then you can have a workable Casimir effect over a larger range of frequencies and more Casimir force. So it's not just the magnetic field confining these things, but also possibly a Casimir effect, which is an interesting thought.
Yeah. So what I'll say is that because I was trying to find an inertial, basically an explanation for inertia that was completely, compatible with modern physics, it ended up being a unification. But it's built on other things. It's not just my work, right? So I kind of did the capstone there and combine things. But
I'm excited to read it.
The update I want to give is that so I finished this like New Year's. Yeah. I don't know, not New Year's, but Christmas Eve. I sent it out. I did all that stuff. I stopped actually working on it because I needed a break. It was like a 9-month sprint. That first draft. So a couple of things. The first draft, is, there are some errors in there. I didn't put the full equation in terms of I don't have the conjugate equation included, which I will have. So if you look, it's based on Mendel Sachs's work in terms of like the covariant part of it. And that's and to finish up what I was saying about Kaluza-Klein, the thing about this extension of GR that I use is that it does not require 5 dimensions to combine electricity, magnetism with gravity. So you have a much simpler thing. But that being said, there is other degrees of freedom in the theory. So basically, you can think of the theory fundamentally as a 4-vector with quaternion, basically quaternion elements. So that's that quaternion part where you have the IJK. That can be thought of as you have extra degrees of freedom, or like you can think of them in the small dimensions. There's other ways to think of them. So it although it doesn't have 5 dimensions, it's 4-dimensional. There is and there's a reason why that is chosen by Mendel Sachs, and the reason why is that is the full symmetry group that you have in GR when you remove the discrete symmetries of nature. And the reason why you would remove the discrete symmetries of nature from the symmetry group that Einstein used is that after Einstein passing in 1955 or 6, a few years later, they found parity symmetries violated, right? They found that on cobalt-60, electrons go a certain direction. So parity symmetry violation is a known thing in nature. And so when you expand the symmetry group, that's the number system you end up with. So that's the physical reason why to use that particular group theory for the theory. And what ends up happening, and this was all Mendel Sachs's work, you have a theory where you can take that and you can recover the equations of general relativity. You can also recover the equations of Maxwell. But also at a low energy limit, you get something that looks, basically you recover quantum mechanics at a low energy limit. So
nice.
That's the basis of what I built. And anyway, so the update is I'm now back on it.
I'll be very interested to read that.
Yeah. It's hopefully you guys like. And also, if you look at last month's APEC, December, or the previous months, you'll see that I gave a talk on it. So
I'll definitely watch it.
Curtis, is that going to come out on like an audiobook version? Because brother, I tried reading your stuff. It put me asleep in like 30 seconds.
No, it's okay, Drew.
But I can listen to you talk about it in that endlessly. So why don't you do us a favor and come out with like an audio where you just read through your equations and explain what all that nonsense means?
That's a good idea. Actually,
really, it really would. I mean, it would help guys like me because
Give us a
I gotta tell you,
presentation.
I'm hoping
Well,
you understand what's going on, because I want to use something magical out of your stuff, but
it reminds me a lot of the quaternion thing. Reminds me of what's been said about Tesla's work, and no, not Tesla's, Maxwell's work. Like his original thesis was using quaternions as well, and then everyone on the internet says, "Oh, something was lost when we moved away from quaternions," and it sounds like maybe it was the symmetry group. That's interesting.
So by the way, so the Rev 2 update, I'm going to be, of course, correcting the errors, making sure that all the equations are. It's not just the first equation, but the conjugate, right? Just like it's like complex numbers. There's a conjugate equation, and you have to do both. The other thing about it is that in the theory, I just took the electron model as, okay, this is what I'm using. But what I'm doing for revision 2, and I've done these calculations already, is that I'm forming an electron by taking 2 gamma rays and running it through my theory just from first principles, just the equation of a gamma ray in my theory, which we know forms electrons from the Breit-Willard process. And I'm getting 2 positron and electron, and that full development is going to be in the new revision. So basically now there's no sources are light, and that's what's why I find interesting what you were talking about, John, is that light being like fundamental in there, is that light actually forms, the solitonic matter. Basically, an electron is light spinning in on, you can consider it momentum space, and the way it's spinning in that torus is it makes electric field point either outward or inward, depending on if it's an electron or a positron, and because it's spinning in a torus, you get that magnetic moment, and so the quantum numbers, all that stuff pop out of the theory. Anyway, so Rev 2, I'm actually doing the full calculation of not just saying, okay, here's the electron model I found from Williamson van der Mark Bicycle Society, which is very well developed, by the way. But I'm taking the gamma rays and I'm doing the full brute force calculation, and that's going to be in Rev 2. So, in addition to the later appendix where I do holonomy and a bunch of different applications, that's like kicking them when they're down. And the other thing that's being included in Rev 2. So Rev 1, one of the things that was found was dark energy just pops out without any assumption. So just so you guys know, the 2 correspondences I used for the theory, one was special relativity, right? The speed of light, because we know that light, C is the gravitational potential of the universe, or inertial potential. And the second one was basic cosmology. So like homogeneity and isotropy at the large scale. And so those 2 things gave me my background field and my spin-affine connection and what I used. And so dark energy came out. Now the thing about dark matter is that I was in the last month while I took a break, I was looking at what other people were doing in the Machian world, and I noticed that there was like an attempt to do Machian Mond, or some kind of way of using Machian principles to explain galaxy rotation curves. So I looked into that, and that actually comes out of the theory as well. So I'm going to be adding that in the second revision. I've done 2 papers, and I'm working on 2 papers that rederive the Woodward effect. One from Andre Aziz's relational Weber dynamics. And what's really neat about that one is I get a formula that actually predicts the direction of the force. Like it tells you that the force goes to the larger mass. And so I was able to recover the Woodward effect from that. And then the other paper, I'm taking Carver Mead's G4V, which is a kind of like a gravimetric type of theory based on Einstein's early work before GR, where he was doing a fully Machian theory. So Carver Mead, I don't know if you guys are familiar with that. It's a great thing to use, but it's basically a vector potential theory. So it's not a full tensor theory like mine. But I use that and I recover the same formula that Jim recovered from Shyama's work. So I have both those papers in development. I've been in contact with Jim's estate about getting the lab restarted. So they're funding the rental of the space, and we're going to be. There's plans to do both the Mega Drive and also the Mach Lorentz thruster. I really like the Mach Lorentz thruster, and I'm looking at both the magnetic rectification and the electric rectification. So there's a lot going on.
Hey Tim, can I do my
interesting? So
yeah.
So
yeah, because as
Drew,
soon as my
Go for it,
dinner
man.
gets here,
Go
I'm
for it.
gone.
yeah.
Okay.
Sure.
Good way, Drew.
Okay. Down here in sunny Florida, been focusing on manufacturability because manufacturability is the last frontier. So I'm going to swing this over. You might have noticed I've been looking over here. It is just the best thing in the universe what Santa dropped off for Christmas this year. Yay, Santa, I love you. We now have a fully operational laser manufacturing process for the manufacture of the warp drive plates. And we can now make them in about 7 minutes instead of 8 hours per plate. And then I had possibly the smartest guy in electrostatics in the country in my lab this week. And no, that's not my partner, who's the second smartest guy. I had his mentor. And we were looking over the testing operation, and we said, okay, everybody seems to want to see an air test. So we took, you can't, maybe you can. It's way back there in the corner, or there is the vacuum chamber. And we took the fully functional thruster out of the vacuum chamber and put it in the room where the air tester is, which is just basically a digital scale, and hooked it up and ran it and got the surprise of our lives. We somehow are making more thrust at 1/10 the voltage as we're doing in the vacuum chamber. So that's really cool. Don't understand how that's working, but since we have video of it, it's pretty hard to argue with. So, it's really cool. We have manufacturability almost down to probably MRL level 5. And we've got an air demonstrator that allows us to demonstrate the thruster pulling up, which is really the tricky one. Pulling down, it can be anything. But pulling up is much more tricky to fake. So it's just, things are really bright and shiny down here in southern Florida. That's it. That's all I got.
Question.
There we go.
John, question.
Drew, first question, where is sunny Florida? Just kidding.
It's just south of Georgia.
I understand.
We're 30 miles. I'm physically 30 miles north of the Kennedy Space Center. That's where I physically am.
So I used to live down there, and the joke was, in order to be in the deep south, you had to go north.
You do. Florida's not in the south.
To cross into Georgia.
Yeah.
Yeah.
Florida's not cool enough to be in the south.
Okay, here's my here's my question. Why does this thing glow? Did you get a nice plasma discharge when you charge this thing up in air?
Not anymore. It did before when we were leaking field, because we're operating way past the edge of air. We're operating at like 10 to the 7th, 5 times 10 to the 7th volts per meter, which is an order of magnitude or two above the breakdown of air. But now that we've got the whole process, we're fully shielded. What we used to be able to only do in the vacuum chamber, because we would just go into plasma hell. Now we can do an open air because, like I said, I've been working on nothing but manufacturability. So my new manufacturability process allows me to operate in open air.
You're doing everything with plates now rather than needles.
I can't hear you, man. You're underwater and breaking up.
Oh, he said you're doing everything with plates.
I remember you used to when I first saw your experiment, you were using kind of a needle electrode, and now you've gone to flat plates, right?
For the most part. Yes.
Okay, that's okay. That explains it. You're interesting, fascinating.
But the original
Me,
patent
I always like to see a
covers
glow
flat
of a
plates
plasma,
also.
you know?
We just use the needles because it makes the most. It's the easiest
very
thing to
good, very
understand.
good.
But all the new patent stuff, it all covers
Yeah.
the flat plate and all the new math, all the new QED math, quantum, whatever QED stands for. I don't know. Charlie could explain.
Quantum electrodynamics.
Yeah, that's
quantum,
it.
Yeah.
So
Well, it also
yeah,
stands
it's,
for thus it is
come a long
demonstrated in Latin. Yes, well, I'm very.
Can anybody else understand what he's saying, or is it just me?
I can understand.
I can hear him.
Really? Okay, it must be breaking up on my end then.
You might need headphones.
Oh, crap. I don't know what to do. Anyhow, that's all I got. Any other questions?
I got a few updates. Oh, yeah. Let's see. Questions.
Yes, you do. You have UAP analysis updates. Michael, can you do UAP analysis? Can you do a screen share?
No, not at the moment. I'm still trying to configure this computer after having reflashed the operating system and stuff. It doesn't, for some reason, screen share, at least in Google Meet. I don't know about here, but even so, the data is at the server at work, not on this computer. However, I can just mention, we finally got around to the analysis of the Frank Kimbler sample from the bounce site at Roswell. So we have SEM data, and it looks like it might be a 3000 series aluminum alloy, wrought alloy. We've been able to resolve the anisotropy in the crystal structure, so it may have been from some sort of deep drawing process or similar. The weird thing about it, like it looks for at least EDS data, it looks like a terrestrial alloy. But when we sputtered it with, I don't know why we sputtered that sample with the. Oh yeah, because it was embedded in a block of epoxy. But we sputtered that with a mix of palladium and gold because that's what they had for sputtering at the university. And the interesting thing is that the palladium gold, actually, yeah, it's the palladium peaks for some reason became absorption peaks. Like there was no signal in X-rays from the EDS at the palladium at two of the palladium peaks at the aluminum surface. So that was peculiar. If anyone can think of an explanation, let me know. But my best guess is that it was a palladium gold alloy on aluminum, and we did the sputtering, and then we did our initial testing, and then a month or two later, we took our final analysis on EDS, and that might have been enough time for a layer of gold aluminide to form at the interface between the palladium gold alloy and the aluminum. So
Michael,
that would have been.
Let me interrupt you for a second.
Yeah.
So from your description, you described it as probably a 3000 series aluminum, but you're also describing some unique features. Do you think that this is a prosaic sample, or is it likely to be either UAP or some kind of advanced aerospace vehicle?
I couldn't tell you on whether it's prosaic or not based off of that analysis. It does look like it was a wrought 3000 series alloy, but like aliens could do that sort of process too in principle. But the weird thing that I'm talking about here is this effect with the palladium, and that may be that either is our instrumentation doing something weird with the palladium signature. It's just, and if it is a gold aluminide layer that's like a few angstroms thick, like 2 or 3 angstroms thick, it's such a coincidence that it lines up with the palladium spectrum. So I don't know if that's a real thing or is just something wrong with the equipment. When we tested other samples, we didn't see that though. So it's a I mean, maybe it's sensor error, but I don't know enough about EDS yet to know whether it's sensor error. Maybe someone who's an expert in EDS will be able to tell. But if it's a legitimate effect, it's very peculiar because you never see like X-ray total absorption like that in the context of this, as far as I know. Maybe Jared has some input.
Yeah. So for UFO samples, one of the more important pieces of information we've gotten from them is the insane array of trace elements within those, right? And because it's trace elements, it's at first it seems difficult, like why would they use so many different trace elements? But when you compare different UFO samples against each other, and you see some overlap, some don't, you combine that with this idea that there's the RF interference, right? So you have RF interference where radios and TV stations, all that go down when you're in close proximity. You combine that with the luminosity observations from it. It suggests that you have a thin surface plasma over these craft. And that thin surface plasma has so much energy to it that it's able to account for not all, but a good chunk of the observable maneuvering that these things do. Well, if you have that level of energy density in the plasma, you're starting to talk about transmutation of elements, right? You're starting to talk about fusion, which that right there is probably one of the better smoking guns we have, is the long tail of trace elements in so many different samples that are suggestive of transmutation of elements.
So for this sample, we did not see a large amount of elements in it. But one thing that was interesting is all of the silicon was constrained to the surface. So either that's some sort of weathering process. It was buried in the desert, so it could have, like, silicon is most of what sand is. So the surface stuff was mostly silicon, maybe because of that. But the alternative is if there was some exotic vacuum object style transmutation on the surface, aluminum to silicon is you're adding a hydrogen atom to the surface. So that's possible that there's like a crust of silicon on the surface because of that. But it's also not, we can't tell it apart just using, we can't distinguish that from weathering necessarily, especially because there was also magnesium in the, there was magnesium in the alloy itself somewhat too.
So different samples have different varying lengths of tail of trace elements, right? And one example of this would be like the 1964 Socorro case, where the landing gear scraped against some rocks, and eventually we got the results 50 years later from that testing. But it was primarily like aluminum, mostly aluminum with some trace magnesium in it, right? Well, that's landing gear. That's like up inside the craft. That's not surface level stuff, right?
Yeah.
And so it seems like for some of the samples that come from the interior of the craft, you see a far shorter tail than for the surface elements, which would make sense if indeed you have this plasma actuator-esque type thing. But going back to...
So Jared, you might be more interested. We also tested the Carbonado diamond samples since we had the lab time at the SEM. And so the Carbonados, unfortunately, we were not able to resolve a lot of metal particles as I was expecting. But we did find one apparently metal particle, and it had like 10 different elements in it. And it was a very peculiar mix. So it was like a little bit of calcium, magnesium, silicon, tantalum, and a couple of other things. So like that sphereol was embedded apparently in the, but it was not. It was weird because it was like embedded in the tape that we taped to the thing. So I don't know why. And maybe it was like just an impurity inside the tape, but it's the composition was bizarre. The other thing is in the carbonado diamonds, we were not able to find metal particles, but they may have all oxidized over time because the carbonados were porous. We did find titanium dioxide crystals, rutile crystals, throughout the entire thing, evenly dispersed at the 1 to 10 micron scale. So that looks like a grain refining agent in the diamond to strengthen it if it was originally a metal, and it would also have been good for sequestering nitrogen, which would have prevented the diamonds from sintering. So it's just interesting to see that there was specifically titanium. There was a little bit of chromium in there as well, but there was a lot more titanium than chromium, which is peculiar because the main theory for that is that it came from a supernova. The other thing is we didn't see any. We saw iron, but we saw effectively no nickel. So if it was from a supernova and it was like asteroidal in nature, we would have seen nickel iron, but we only saw iron like rust particles. Although those could have been from the fact that these were just sitting in the earth for 2 billion years. So but it does just based on the very even distribution of the titanium crystals, that seems to suggest it was engineered for mechanical strength, assuming that it was a composite.
One angle that hasn't been presented yet that should really have a good presentation put forth is a head to tails summary of all the observables from the UFOs. Because as I continue over the years to hear different people try to come up with hypotheses for these things, there's always some observation that's being left out. And therefore, the hypothesis ends up being skewed because it's not accounting for X, Y, or Z, right?
Hey, Jared, sorry to interrupt, guys. This has been fascinating. I have a hard stop at 7 o'clock, and it's just after 7. But, Jared, Chad and I have added 5 more observables. There's now 10. And I think people need to read that. And it's now starting to be accepted, the additional 5. So we're up to 10 now. We hope to show the rest of them. But this has been fascinating. I really appreciate the invitation that Tim extended to Chad and I. And as I said, I got a hard stop. I got to listen to you guys talk all day, and then you'd get me going, and I would be here to midnight. Thank you.
Well, I definitely would like to.
Absolutely. Yeah. And I think we're kind of in open discussion now anyways. So.
Yeah. Anyways. Thanks, guys, and hopefully I'll talk to you again. And I sure got a few emails to send out. I'd like all you guys to contribute to our next paper.
See you around, Dave. Let's chat more.
All right, thanks. Bye.
Hey, Dev. Thanks for showing up. I have an update,
David.
Oh,
Curtis,
okay. Mark, no, let's go. Hold on. Mark, let's have Mark go. Mark,
I did have one more. Well, I did have one more thing to add before Mark goes, if that's okay.
I'm going to have Mark go now.
Okay. So what we've
Mark, unfortunately I have to go. I have a hard stop.
Okay. John, thank you, sir.
So in the vapor deposition room,
thank you.
We've been working on our vapor deposition machine. There was a couple leaks that we fixed, and we successfully plated objects with both aluminum and iron using just thermal vapor deposition. This glass has actually aluminum visible on this side and iron visible on this side. And you can see, I don't know how well it shows on the cameras, but you can see the different colors of the different metals. So this is actually an iron reflection. This is what an iron mirror would look like if it was actually a thing. Here, I just made it. I had a couple discussions with Drew, and he was saying we got to buy like a $50,000 machine, but using just some ingenuity and some tungsten and iron, basically winding the iron and the tungsten together. We tried several different methods of how to braid them together, and it gives you these like one shot of plating iron onto different stuff. So one of the samples, one of the first ones we did was ironed onto the polarized aluminum. That's aluminum that has been cast inside of a magnetic field. That went pretty well. Ned Pavlovic, who was here, suggested we try plating powder. That's the next thing we did. We plated some nickel powder, some aluminum powder. You can see it over there, actually. And then I mixed the powder in with epoxy and impregnated it with a little bit of xenon. This is the result that we got. Some of the metal did come down to the bottom. This is going to be one of our next samples. Inside of the setup right now, we do have the sample of polarized aluminum. While we were talking, I actually figured out a better way to work with our bipolar power supply, the one that creates the B field pulse, and found that if I hooked it up onto the voltage side, it actually gives me a much cleaner output signal. So that's how we have it running right now for this test. The laser, the geospace laser in the back, that is up and running again. We've gone through a couple KTP crystals. Those are the frequency multiplying crystals, and that's all working pretty well. And I think that is it for our update. I do have some data that we're looking at. I've seen some promising smudges, but it's not to the magnitude that we'd like.
Awesome, Mark. Thank you, man. Thank you. Okay, so we will officially go to open discussion. Oh, it looks like okay, Michael, you had some stuff. I cut you off. What do you got, buddy? Okay, you have to unmute yourself though.
Right. Hey, Mark.
For those,
if you've got an XRF, you might want to check that whatever you deposited. You're probably going to have some tungsten mixed in with your iron.
Yeah, probably.
Yep.
Yeah.
I know that there's definitely iron in there because it is the powdered aluminum became magnetic. Very slightly.
Sounds good. So, guys, so I was just going to mention for those who were not familiar, the hypothesis with the carbonado diamonds is they're extrasolar, and possibly from a von Neumann style probe that was sent to Earth 2.2 billion years ago. It's interesting that photosynthetic life appeared at similar time. If you wanted to introduce photosynthetic life to Earth, you'd want to oxygenate the region around the ship after you got here. So it's interesting. There's a mineral called bahianite, which only is co-located, as far as I know, with these carbonado diamonds in the two locations that they show up. And so we were able to show that you could make this bahianite mineral as a concrete instead of like hydrothermally. And when you do that, it releases nitrosyl chloride, which is a good oxidizing agent. So if you have an anoxic environment that you're trying to introduce oxygen-breathing life to, it might be a way to sterilize the surrounding area before putting that life in that spot. So it's interesting. And also this bahianite concrete that we've produced seems to have a Mohs hardness of 9. So it's as hard as sapphires. It's crazy stuff, mechanically speaking. Very peculiar material. But we can finally produce that. And we'll probably send some for analysis along with some original bahianite samples to see if that fully explains the composition or if we've got it wrong. Anyway, that's it.
You actually believe von Neumann probes exist? Like, if they had the ability to travel interstellar, why send a probe? Not just come in person.
Well, I mean, it depends what level of tech development, what
2 billion
species.
years ago, the Earth wasn't all that exciting a place.
There's a very good reason for that. So statistically speaking, they're estimating, if you take a median, there's a median of 250 billion stars, Milky Way alone. And you could not produce enough ET craft and crews to explore any of those in civilization's lifespan. But what you could do is create one self-replicating probe And within 50 generations, you would be able to put a probe on each one of those. Now, if those are sublight, which we're assuming, right? I mean, that's the assumption is that they're sublight. But even if they're instant, even if they can instantly get from one to another, it still takes time to self-replicate and all that. So the job of exploring and all that would just take too long. So it's statistically far, far more likely that we will encounter robots before we encounter people or other beings or whatever. Even if they're out there, even if you've got ET out there cruising around UFOs. Now, the argument for aliens would be that a von Neumann probe found us centuries, millennia, millions, billions of years ago, and it said, hey, life's a great place. Or as Michael was alluding to, maybe it even seeded us, right? And that could be another function of probes like that. So the at least initial contact is like trillions of times more likely with robots than it is with actual aliens.
It's easier to explore deep time than deep space for the time being.
Yeah, but it's also entirely possible that a robot found us a long time ago and phoned home, and whoever built it showed up later. So
that's also true. You know, when you're setting up like I don't know, some sort of portal system and stuff, maybe you have to slow boat it initially, and then you can do fast transport after that.
Do we have any statements about what's going on with Trump and Obama and presidential disclosure?
Chaos as usual. That's my official statement.
I saw Trump went from 10% tariffs to 15% tariffs. Like, depends on what he had for breakfast.
You know, I guess the question I would have is, they always have, I mean, whenever you talk about declassifying stuff, they always poop their pants, freak out, and say, oh my God, but wait a minute, people are going to know. They'll know that we have like spycraft and nuclear missiles. Like, we can't let them find that stuff out, right? Like really obvious stuff that everybody knows. So they have to black it out of their reports. So how are they going to declassify this stuff now? I mean, how is that any different than before? Or are we just going to get, is it going to be like the Epstein files, which would be okay if they black out like all of the names, you know?
Well, fingers crossed that the things that are discovered out in the open are let out fast enough that they'll have no choice but to also, like, it won't be possible to hide it at that point. And it does seem like John Brandenburg was allowed to replicate some of his previously classified stuff in an open form now. So that's encouraging to see. So maybe they will do it.
That was probably just government incompetence.
Yeah, we'll see.
Yeah. I try not to think about it too much. It gets too depressing.
Jared, what's going on with the Graviflyer?
I was waiting for that.
I heard Jared has a bet on 2027 disclosure.
Yeah, so you can actually like put money down on all sorts of different events now, right? It's called the prediction markets. And the one good thing about those prediction markets is, just like stocks, all of the smartest people with the most up-to-date information, they end up, you know, buying or selling those things. And so you can go off the prices of the prediction markets. It's kind of a relative idea for some of these other concepts like UFO file disclosure, aliens are real disclosure, that sort of thing. Well, at the end of 2025, there was I think they have like an annual one every year, like the president will disclose alien life before the end of year X, right? So the one for last year, it got up to like 90% probability yes. Like there was some weird stuff going on there. It's just like the stock market, you'll also have people like manipulating the prices of things, right? So that they can make more money. And so it kind of looked like that's what might have happened. Anyways, right now, the prediction market that I'm in is the one for 2027. 2026, like the president will reveal the existence of aliens prior to January 1st, 2027. And that market has done some steep upticks after the recent Obama-Trump, coming out and saying shit. It still is at like 25 or 30% likelihood, but if you got 20 or $100 to throw in it and go like, it's a fun sort of thing. You could 5x, 6x your money if you were into it for money. I'm more into it for just being able to observe the market, right?
Are you able to cash out early? Like,
yeah. So I was really tempted to cash out like a day or two ago when it had this really quick spike, because that was all like media hype spikes, and I would have doubled my money, right? But it's this whole thing. Very few of us are in this for the money, right? It's more in it for the passion of the thing. So I just soon ride the whole thing out and watch the whole thing play out.
Wait, is that a polite way of saying you only had $20 in it, so it didn't matter?
No. It's, again, money is the side part of all of this. The better side of this is as a stats indicator.
Okay. Yeah, so $20. That's all we had in it. That's why.
What happens to the petrodollar if we get free energy, though?
So on that front, it's worth noting cryptocurrencies, despite the fact that cryptocurrencies have taken like a massive 50% nosedive in the last 3 or 4 months or whatever, right? We hit all-time highs back in October or December, and since then it's dropped by half, right? So it's worth noting that JP Morgan, right, Chase, as well as Eric Trump has a $3 trillion valuation crypto thing going on for Bitcoin. A lot of different really big players right now, despite publicly saying we are not for crypto, they are actually in the background buying crap tons of crypto even as it continues to tank. So that petrodollar thing may very well be related to, in some fusion release type tech, where petrodollar ends up going to zero. At least there is some other transitionary thing that you can guarantee the Fed will end up shuffling those shells.
We should make a currency based off heavy water instead of oil. Anyway,
so no, I guess no Graviflyer update. Darn, Jared, I was going to ask you about that. Did you see that Bismuth talk? Do you have any comments on Bismuth?
It's none of your bismuth. And talking about bismuth, that guy who was talking has one of the biggest stakes in bismuth in the world, I think.
That's not surprising to me.
He's very bullish on bismuth.
Well, it's the only metal that's rarer than silver that's not expensive yet. So
Bismuth, one of the things about his
can't
talk
go wrong almost.
One of the things about his talk that almost got there, he was getting close, somewhat close, but he didn't get there. Bismuth has, like many things, has a couple Raman modes, a couple lattice vibration modes, right? And one of those two modes happens to be where you have some of the most extreme anisotropy of electron transport in any known materials, right? And that's just because it has a trigonal axis, right? And one axis of it goes as the others do nothing, right? And so that one axis is like birefringence almost of electron transport, right? The electrons go really easy this way, but either go super fast or super slow the other way. So that is super interesting if you start combining that particular reaction of bismuth at that frequency of about 2.7 to 2.9 terahertz. If you combine that with other materials that also have interesting electrodynamic property changes at the same frequency, when you start doing terahertz engineering on these materials, you have overlapping frequencies with very constructively combined effects. That's where I would start looking. As far as like being able to levitate a magnet between two pieces of bismuth, whoop-de-doo. I don't
Yeah.
care about that. I care about being able to, 10x or 1,000,000x an effect by stimulating at the proper frequency.
Yeah. So Jared, one question. That exact structure you're talking about, that would not be made just by simply sputtering bismuth, right? You have to go through a process.
So there is a specific size of bismuth that works for this, right? You need to be dealing with thin film bismuths, and because you're dealing with these frequencies, you can't have super large amounts of this bismuth over a wide area. So you have to have arrays of 1-inch squares that are tens of nanometers thick, right? And then when you're stimulating that at this frequency, that's where you'll actually start getting some of this effect. So the orientation of the grains of bismuth matter, but they don't matter if you're dealing in that thin regime, because they're all going to be aligned in the same way in that thin regime until you get too big, and then you'll have defects that throw off the whole thing.
Right, and that sample we were talking about is about that size, right?
Arts parts?
Yeah.
So arts parts is kind of weird, because rather than operate off the thin film, the bismuth in arts parts is composed of these balls that are 30 nanometers at the smallest up to about 1,000 nanometers at the largest. And there's actually a good reason why you would want to have it that way, and that's for thermal protection. So the thin film bismuth, if you hit it with too high of an amplitude, the whole thing's going to melt. You're going to have defects up the fucking wazoo. But if you have a bunch of these little balls that are at the proper thickness, the thermal transport between those balls is going to be mediated by whatever bulk they're embedded within. And if that bulk just so happens to be, say, magnesium, that also happens to have the same frequency response when doped with really other useful stuff like zinc, now you can get the extreme dielectric response of the magnesium combined with the electron transport response of the bismuth. But the magnesium one only happens at a certain temperature, and that temperature is too high for the bismuth. So that temperature for the magnesium to do that is 500 to 800 C, with 650 being the ideal for the frequency overlap between the two. So you need to be able to pulse the bismuth and magnesium in such a way that the thermal doesn't build up, that it can go through all of the bulk magnesium, disperse through all that before it builds up and it melts all your bismuth so that you lose your little balls. But you wouldn't even be able to do that if you're using thin film bismuth.
Right. Okay. Yeah, because remember that when we're talking that crazy talk that during that open mic, I looked into things, and yeah, that's the conclusion I had about doing films. It wouldn't work. So that's interesting. I didn't know about the spheres.
In the Aero paper that they have one really good TEM image of the bismuth layer, and from that they have the scale bar there. So from that you can pixel count, and you can see how large these balls are.
Yeah.
And it's funny because it was the discontinuity of the bismuth that is what resulted in Aero saying there's no terahertz of any kind here. Ignore all things terahertz here, because that bismuth can't be a waveguide because it's discontinuous. Ergo, no terahertz to be seen here. Ignore this. Eric Davis kind of iterated that extremely strongly to me. That the full report says there's no terahertz because the bismuth is discontinuous. So
I still think it's something nuclear related, but we'll see.
We don't know the total amount of uranium in the sample. We just know it's present.
And we know that Aero didn't mention it also.
Aero purposely didn't mention it because it shows up on XRF, which is like a 5-minute test.
They can't. They would have to get a DOE permission.
Exactly.
And they're
they
not
probably
give
didn't
any permission for any of that.
Yeah.
I mean, they are the DOE. Oak Ridge, they're far enough up the food chain that They have no
There's
good
still-
excuse here.
Well, there's still like, I mean, it's easier from a regulatory standpoint to talk about it if they don't mention that.
Also,
fact.
if Kirkpatrick hadn't been involved in all of that, they'd have a greater leg to stand on.
Is Kirkpatrick still involved?
Yeah.
I don't know if he's still working at Oak Ridge or not, but what I do know is that when he got fired from Arrow, he had already like just swept right into Oak Ridge, and he was the chief scientist for Oak Ridge that was responsible. That was his primary responsibility, was that report, right? Which talk about interesting to go from Arrow to the leading national lab for this kind of testing, and you know he's basically governing what goes in this report and what doesn't. After governing what goes in the Arrow reports and not.
I met him in person at the hearing. I was there with Jeremy Reese and Senator Gillibrand and everything. He looked very shifty. Didn't really want to answer real questions. Was just running off real quick.
Yeah, he was trying to cover stuff up.
And he knew it too.
Yeah. But thankfully, it seems like those people are kind of like falling out of favor. We'll see.
No, there was his replacement was a guy who was only there for a little while. And then after he left, that guy went on somebody's podcast that I talked to, really small podcast. And he revealed some very interesting stuff about Arrow and quickly shut the heck up after that. And his replacement has been far more...
the replacement of the replacement of the replacement?
Correct. So the latest guy that we have now, far more even-keeled. But behind the scenes stuff, Arrow is still playing incredibly dirty. Like, really, really dirty. So I would strongly advise any and all people to refrain from contacting Arrow about anything UFO related, because normally I'm all for like trying to help the government along as much as possible, but not when you're talking about a government branch whose specific duty is the exact same duty they had back in the 60s with the Condon Report, where it was their job assigned by the government to try to tamp down this information.
Yep, sounds about right.
Well, Trump just tweeted that they need to release everything, and Pete Hegseth's response was an alien emoji followed by a salute. Yep. I love that. I reposted it with alien and salute.
Now we'll know if they're serious or not, though, because UAP GERB has already done more work of higher quality than everyone else before him combined, and he has already named the names. He's done all of their work for them as a single guy and as part-time. He has done all of the work saying, this is a hostile witness. They are strongly involved in the program at a high level. Get them in front. He's done that for like a dozen or 24 people, right? So there's no excuse anymore for them not to bring forward people to Congress.
Yeah, shout out to UAP GERB. That's an amazing job he's been doing. Amazing work. Very thorough. And like, yeah, if they still don't do it, then they're probably complicit.
Up until now, their excuse has been, oh, we just can't get access to the people who are in the know. They don't have that excuse anymore because GERB has removed that. He's like, nope, here's the receipts that get you from point A to point C, and here's the person at point Z that is obviously currently involved in this
yeah, it's been very impressive to watch. Yeah. Definitely going to send him that timestamp.
The angle, instead of Graviflyer updates, the angle that I was going down this week was trying to go through observables and compare those to the energy requirements, right? So sometimes saucers will go like flat end against air, which is crazy. Other times we'll go edge on against the air, which would make the most sense. So it's in those instances where they go in the least efficient way, like they were for the Nimitz encounter, where they were going flat side, broadside from 80,000 down to sea level. When you do the math to figure out how much energy it would take to move that volume of air out of the way for it to do those accelerations and those velocities, it's terawatts, right? You're in the terawatt regime, which doesn't work. There's no way they are producing terawatts of energy.
Well, yeah, but like you're assuming that you're probably not assuming a warp field though. If you have the warp field, you can push the air out of the way.
If you'd let me finish.
Okay.
Let me finish. So the first problem is you have to account for moving the air out of the way, that's a hard problem, right? How do you reduce that 1 terawatt down to the couple of gigawatt or even half a megawatt? I mean, half a gigawatt, 500 megawatt. Just for one of these craft that is a 10 meter diameter saucer, according to Ted Phillips' landing impressions at landing sites, we know that these 10 meter diameter craft weigh between 8 and 15 tons. So now we have data required to do the math on, well, how much energy is required just to keep one of these things aloft? And you're still talking like 100 to 150 megawatts of juice just to have this thing floating, right? And that's if it was using conventional propulsion. So to go from the terawatt down to the strong megawatt, low gigawatt range, you have to combine the plasma that we see from the RF interferences as well as the luminosity. That's the plasma. You have to combine that with the metric changes, and that is that missing component, is how much. I was really hoping Chad and Dave were going to get into the math on that. How much warping are they seeing? Because I will suppose that they are within an order of magnitude for their calculations for the difference required to go from the luminosity output during accelerations of approximately 500 megawatts to a gigawatt, that we will see that approximately 1,000x difference in energy requirements for a terawatt down to a gigawatt, right? If their warping shows that, it's going to be super close to the surface, like Drew's stuff, right? Drew's stuff is magical because, like you were saying earlier, he puts in just teensy tiny amounts of energy, and yet he's doing some kind of warping here. So there's some missing link there between the plasma required to move the air out of the way and the amount of compression of space-time required to make that plasma effective enough to be able to overcome the energy requirements.
You know, guys, I really think that our propulsion is kind of a byproduct of an energy harvesting. We're sort of setting up some kind of a, it's kind of like throwing by mistake, you throw a trap, you throw a net in a river, and all of a sudden the fish just pack up against the net. And the fact that the fish fall up against the net and push the net is kind of what we're seeing. We're not seeing the fact that we somehow are harvesting fish or energy. We just see the results of it pushing against the plate and moving the plate. But the energy considerations are ridiculous. I mean, we're putting in microwatts, milliwatts, but we can put. I've had 40 plates connected together and putting in the same milliwatt range. I mean, it's not a couple of milliwatts per plate. It's a couple of milliwatts just to get the stupid system running.
So, Drew, have you tested the direction? Have you are you always testing with the plates sideways, or have you tried facing them upward and downward?
All 6 cardinal directions.
Do you see any difference between them?
No.
Interesting.
They produce the same. Like, for example, the air test. It's vertical and horizontal. Or I'm sorry, it's vertical. It's up and it's down.
So the flow.
And it makes the same amount of thrust up as it does down.
So if you're seeing like a Venturi effect, like if you're seeing like the sort of, let's say your electric fields, you're creating some sort of wing and you have some flow over that wing and it's pushing in some direction. What that is suggesting to me is that whatever flow we're talking about would have to be oriented in the time direction.
Well, it's definitely oriented in the field direction.
If you have a wing and you have an orthogonal direction where you have a flow, then it's going to get pushed wherever the wing. You're adding some structure to that wing. In this case, you're creating something like a wing by misshaping these fields. But let's say
first of all, your whole wing theory is wrong.
Well, I'm just saying, if you have like an energy harvesting, that's the simplest model you might go with.
The closest thing I can come up with is there's a river, and if you're just looking at the river, you ain't getting no fish, and your net ain't moving. It's just hanging in the breeze. As soon as you dip it into the river, all of a sudden the drag of collecting fish push the net, and then you feel a tug on the net. That's very much like what we have. Nothing happens until we energize the field, and then as soon as we energize the field, it's got to be harvesting energy from, whatever, subspace, whatever, the virtual photons, whatever the heck we're doing. Charlie says we're creating unmatched virtual photons or something. But we're harvesting energy because, the amount of energy we're putting in sure ain't lifting these plates.
Yeah. So that's so if you just have an electrostatic field, you can certainly produce forces like that, in principle. But I mean, if you're assuming that you have photon pressure,
eating?
It's late, I guess.
What are you eating? What's the deal?
I actually should head out to dinner soon anyway. So,
so Drew, your stuff, because you have a dielectric and you have electrons that you're using, a feather to put those electrons in there, right? It's no power to get those electrons stuck in there, right? So it seems like the energy that dielectric is using to hold those electrons back from going to the ground plate, that energy, that's mass, right? That mass energy of your dielectric sticky plate, that thing is doing all the work of preventing that really close interaction there from depleting. And I would venture a guess the amount of energy that is stored from that really strong electric field, that's probably where you're stealing stuff from, is you're allowing a natural progression of this electron to flow to where it wants to go. And with geometry materials, stopping that flow right as it's trying to go over the waterfall, right? You have a ledge below your waterfall of electron going down to the ground, and that's your net. You're catching it that way.
I think it's almost like piezoelectricity. When you take something and you squish it and it generates charge or shocks or whatever, little lightning bolts, and you squeeze quartz, piezo. It's almost like, because when we activate the field, the Coulomb, this thing has a Coulomb crush, okay, and it's 4 orders of magnitude greater than our effect. So the Coulomb field, Coulomb attraction is trying to smush, it's just trying to crush the structure. So that's actually putting the atomic structure under stress, and that stress is coming from the field. We are somehow riding that wave.
Drew, have you seen the NASA paper where they had that giant particle accelerator thing that you accelerate it up to some high speed and then you turn it around and then you would decelerate it and then you turn it around, and they were able to show that this produces a very small force that's relativistic in nature. So when the thing's going fast and then it turns around, then they get more force than when it's going slow and they turn it around, even considering the acceleration and deceleration along the line.
No, I didn't see it.
So basically, if Curtis Horn or his model is right, or if a similar model is right, and you have some sort of electrons that are topological knots of a sort, then if you squeeze the electron cloud, so maybe it's like narrower on one side and bigger on the other side, that electron's orbiting around possibly close to the speed of light. So you could get a large relativistic effect by squeezing the shape of that electron orbital so that it's narrower on one side and bigger on the other side, and then you have a big relativistic effect, big acceleration on one side and a small acceleration on the other side on average. So it might end up being like it could even be a relativistic thing as opposed to quantum mechanical.
Charlie's got about 50 pages of crap on that. Something called hidden momentum or something. It's why the thrust in the actual metal plates is an order or two magnitude less than the thrust of the embedded bound charge.
Yeah.
There's like 50 pages of crap about that.
Drew, when are you going to do a spinny thing?
No, I'm not doing any more spinning things. I gave up on them.
No.
No.
We just picked up, this is David Chester picked up a glass vacuum bell jar with an opening on the top.
Oh, good.
You could put a high voltage line in from the top.
Yeah. Yeah, I did spinning things for years. Nobody cared. Now I'm doing things that people care about.
Drew, I have a Graviflyer you could put some stuff on and make a spinning one.
Yeah, you say these things, but I don't see any Graviflyer crap behind you. I see. What is that? What are you pointing at? You're pointing at something.
That's the Graviflyer right up there.
Oh, is it really?
Yeah.
When do we
Did
get
it
the
get
tour
up there
of the
by
new,
putting
the
it
new
up there, or
digs
did
there,
it
Jared?
fly up there?
Right there.
When do we get the tour? When do you walk around and say, this is the accelerator, this is the...
We can't hear you, Jared. You're muted.
There's a workbench. There's shelves. There's a printing bench. There's a workbench. Yeah.
Where's the accelerator? Where's the camera thing?
I'm with Drew on this, by the way. Yeah.
Soon
well,
enough.
You can't really see out into the shop right now where I have
there's the
Oh, is that where the alien autopsies are done?
that's the Faraday chamber. It's slowly getting finished. Yeah.
Well, I better step out for dinner, but always
That
fun
room
talking
is
with you guys. I'm glad to be back. Yeah. See you guys next time.
Hey, Mike.
I've been running this experiment for a few runs. I'm seeing something happening here. This Alzaphon thing. This is the first time I've ever done it where you got a really sharp peak on the B field modulation.
Did you remember to turn on anti-gravity mode?
Yes, anti-gravity mode is activated.
What about anti-inertia mode?
I don't know. I only have anti-gravity mode. So check this out. There's like a really strong thing over there, and then it got a little weaker, but it's still showing up. The first one was a lot bigger, though.
What's the Gauss at that peak?
They're all the same at 1100, which is a little above where I expect it, but because the B field modulation, it could be that's actually where it's supposed to be, because there's B field modulation going on. I'm going to go and recouple it for a moment and see if I can make that happen again.
Well, one of the cool things that's happened here is the new manufacturing process has allowed me to switch to thinner and thinner materials. So I'm getting the same thrust off with thinner materials. So I'm actually headed back towards Earth Unity. And there was a thing years ago where the guy from Skinwalker Ranch was messing with some foil or something, and he put like a 9-volt battery across it, and it like jumped up and floated or something. We're not too far from that. We're at about 50% Earth Unity on a free floater right now.
After how
control,
long?
but so
How long is it taking you to get up to that level?
it's damn near instant now. There's some very curious things are going on with this air testing.
Oh, really?
I thought it was ion wind, so I built an entire ITO shield box around the stupid thing to prove it wasn't, and it's not. It's getting up to full thrust like within seconds, and
The only difference is that it's not in vacuum chamber.
it's outside. So we were thinking that maybe there's so much inertia and so much working against us in the vacuum chamber that maybe we've been making this much thrust all along and just didn't know it.
I wonder if
That's a theory I'm kind of looking into right now.
if we step out onto a limb with your whole like catching fish analogy, wonder if the vacuum chamber could be like a shield against whatever the thing is that you're catching, right?
Well, no, because we're already in a little ITO shielded box, so we're in a Faraday cage to begin with. My thing, the throwing the net in would be between the plates, so it'd be a really thin net because there ain't a whole lot of distance between them plates.
Drew, that hypothesis assumes electromagnetic only.
Electromagnetic? I don't know that we have any magnetic component.
Well, you're saying a Faraday shield. Faraday shield is meant to block electromagnetic.
Whatever. It's a transparent metal box.
Yeah,
so
yeah.
It's blocking the electric field from getting anywhere. Also.
Right, but what Jared is saying is that extra material could be blocking something that we don't know.
Unknown particles, muons, neutrinos, hell if I know. But whatever it could be an additional thing or the main thing that is actually causing your thrust. If it wasn't just the electrostatic that we thought this whole time, right? If it was some kind of flowing particle through space that your thing is catching,
I mean,
we know that it's the same in all directions.
And that
I live in a steel box.
That could be tested by putting additional material around it.
Well, I mean, again, I live in see the wall back there? I live in a steel box. It's steel all the way around the building. So I guess, except for the concrete, I guess it could be coming, their magic could be coming through the concrete.
Oh, well, the concrete is ground. That's the definition of ground. I just want to take a moment, guys. There's 170 people in this YouTube stream, and we only got 2 likes. Can we help the algorithm a bit?
That's 2 more than we deserve. We're pretty obnoxious people. Why would anyone like us? I tell you, I got my first intern. We actually have an intern working for us now.
Oh,
and,
nice.
It's refreshing because he don't know nothing. So, and you think that's useless, but it's not. He don't know how to do it wrong.
And you got to explain it to them and dumb it down. Then you realize you don't know what shit you're talking about.
Well, today I explained to him how to use a digital voltmeter because he'd never seen one. And poofed. In 30 seconds, he understood what all the things done on a digital voltmeter did. It's not like I had to argue with him. It was refreshing. Yeah.
Did you find him by posting a job or a friend of a friend?
It's friend of a friend.
That's
the
way
son
to do
of a
it.
friend, actually.
That's the way to do it.
Yeah. And he's going, God help him, he's going to go become a physicist. He's got the wrong role models in life. So I'm trying to talk him into going to become an engineer. Because the school he's going to is noted for engineering, not for physicists.
What school is that?
It's the one over in Orlando, whatever the big state college is in Orlando.
Robotics engineering. That's anyone who graduates with robotics engineering right now is guaranteed to have multiple job offers.
Maybe.
Until the robots can build the robots.
Hey, did y'all see that the guys who they start out with just plastic pieces and then they weave the stuff around it and it's just a weaving process. Okay, I'm a weaver. I have built looms. I think that's brilliant. They wove in where the tendons go and they wove in the joints just by the absence of material. It's stinking genius.
I saw they also were weaving in like wires for sensors and stuff, so you can have like pressure sensors in the fingertips. Like it's really smart.
Yeah, and I don't know. I just thought I really do appreciate good engineering when I see it. Unfortunately, I'm in the space program, so I don't see it that often.
Are you guys gonna buy a robot to help you soon, Drew?
I don't know. It would have to be pretty. It would have to be pretty medical oriented. It would have to be able to be like a person, helper, like a real person. It would have to be able to do everything a real person can do. But I don't know. I mean, 40, 50 grand, whatever the price is, it's in the zone. I mean, shit, cars are 80 grand now. So
you can get a Cybertruck for 60 grand now.
Yeah, but who would want one?
They're pretty cool.
That's why the price came down.
Is dinner ready? Okay. Gentlemen, the dogs have been fed. It's now Drew's turn. Y'all have a great evening.
Live long and prosper, Drew. I love you. The dogs have been fed. Now it's my turn.
Yeah, that's what I've been doing. I've been eating popcorn. I'm starting to run out of that and loading up on caffeine. You guys
when
learned
Drew first came to APEC, he was like so standoffish. Now he's the main show.
We did pretty good today, guys. Thank you for showing up. Even Michael showed up. He has been a stranger for quite a while. But
that is impressive. I didn't expect Michael to be here.
March is going pretty good. I won't have a studio set up by March. I'm traveling, you know, but I think I'm doing okay. I did not try and use my studio mic because last time I tried it echoes worse than this. So I was like, okay, it's either low quality sound or high quality bad echo.
You know, Tim, what you can do is you can take all those sound baffles and put them onto like boards and have them like movable so you can like bring them into a room and make it into a temporary sound studio for when you need it.
Yeah, that's what I think I may do. You know, and I'm still just getting everything organized. You were talking about the APEC reach. We have a pretty hefty reach, but part of that is because I'm taking, like, I mean, not only have I added to the website, the All Propulsion website now is over 250 pages, probably 75, well, I mean, only 80 something of those are conference presentations. Everything else is either like conferences that I've broken out, put up individually and described in detail, or stories that I've written. And so it's kind of a combination of those things. So we have a lot more reach because of that, and it brings it all back to the APEC. So, and I'm still working on all this stuff in the background, you know. So we're kicking butt. We're kicking butt. And then I don't know. This Trump announcement is interesting. It's hard to see which way it'll go. I'll tell you, I felt so disappointed. The one that got me was Arrow released basically a knockdown on the Agua video. And that is one, they did that last year. I don't remember if I saw it, but I didn't pay much attention to it. So maybe I missed it entirely. But they basically said it was 2 Chinese lanterns. And I'm like, that has had so many PhDs look at it. That was the one that Thor from the UAP, he back in 2000, he did frame by frame analysis. He's like, here's where it's going into the water. Here's where it's coming back out. Here's this, here's that. I'm like, it is obviously not 2 Chinese lanterns. And I'm like, so what is that? I'm like, I don't even think of it as conspiracy. I just think of it as we don't want to deal with it. You know, conspiracy has like motive, right? Like, this can't get out. I think with Arrow, it's more like we just don't want to deal with it. It's going to cause trouble. So just explain it away. We know people are going to complain, but hey, guess what? It doesn't matter because we're the government.
All right, I think I'm out, guys.
Well, why don't we shut things down? It is just about 5 o'clock for today. This has been APEC for February 21st, 2026. We are kicking butt in March. Actually, we have more people competing to present in March. So I'm super excited. Things are doing well. Thank you guys. Thank you guys for being here today.
Thank you, Tim.
Thanks, Tim.
Thanks, Tim.